This is a big one. This is the Rolls-Royce episode. Can you believe it, Vinod, that we've been to Rolls-Royce?
It's crazy. I can't believe we made it there. And
oh, yes.
Yeah.
We needed luck. No, we didn't. These guys were awesome. We'll tell you a little bit more about this.
I just want to tell you both good luck. We're all counting on you.
For those who are new, because undoubtedly there will be a lot of new people listening to the podcast. We're an air travel show. We've been around for more than 10 years. We have an episode every 3 weeks, I would say.
Yeah.
It's long form. I babble a lot. Vino talks a lot. Alex, when he's here, talks a lot. So it's
And we laugh a lot.
Yeah, we laugh a lot. 2.5 hours. It's always recorded as if it's live. It's raw. We added a video recently, though the video here, it's not the greatest. It's maybe not the one that will convince you to switch your video, but most people just listen to this podcast. Vinod and I will do a post-game commentary at the end, so stay tuned after this fantastic, honestly fantastic, I still cannot believe it, fantastic interview at Rolls-Royce. So let's dive in. For Gen Kadai, here's the music.
Welcome to Rolls-Royce.
Oh.
In case you hadn't realised, you're in Derby. You're in the Lombard building in Derby, which is the main, I guess, historical centre of Rolls-Royce.
Mm-hmm.
We've got the room. We're kind enough for colleagues to not have kicked us out of the room. So yeah, we're all good today. So I'm Ben. I work at Rolls-Royce. I work in the communications side, but I'm also a massive Layovers podcast fan. I've been listening for many, many years.
Yeah, you said 2015, right?
Yeah, around about then.
Yeah, which means that you listen basically from the start.
Yeah, effectively.
That's my God. He has the receipts.
I have got the receipts. And also, I think I started at like episode, I don't know, 40 or 50, and then went back to the beginning and listened to them all from the start as well.
Oh, wow.
And
You're one of those.
I'm one of those, yeah, sorry.
One of those. Wow. No, don't be sorry. We appreciate it. Who's next to you?
Next to me is Stefan Wagner. Stefan's one of my colleagues, and he is kind of epitomizes what makes Rolls-Royce special in terms of engineering expertise. He's a turbine specialist.
Yeah, I'm Stefan. I'm a specialist in the turbines design team. I've been with Rolls-Royce for 27 years now, and
Wow.
Always in the turbines department. And these days, I'm sort of looking at turbine blades and how to make them even better than they are today. So looking at future strategy, future technologies. But yeah, I've got a fairly long career here and really enjoying it. It's a really, really interesting job. Every day is a learning day.
And as we just saw, Vinod, you just said doing them better than we're doing today. Doing them today is already quite something.
It's it's amazing. Yeah. What we've seen today.
What did we see?
We saw the inner workings of an aircraft engine. Our friends here were kind enough to tour us and show us how engines get made. I mean, just the one component in the turbine facility, and it's something I would never have thought of, both in terms of the technology that goes into it, and more fascinatingly, the size, which is a lot smaller than what I expected. But it's incredible what goes into it. And I think the passenger would never, and I think you said it earlier, they don't necessarily need to know, the inner workings of what's happening outside on that wing, but it's also amazing for them to know as well. And I think we can get into that a little bit today, which would be really awesome. So yes, thank you.
But first, I think we need some context. I mean, we have the context of those guys. I'm guessing most of the people listening to this podcast know that Rolls-Royce does engines for aircrafts. But however, and maybe this is something for you, Ben, do you think people realize as much as maybe this audience here does, but do people in your friends that are not into aviation, maybe because they know you, but do they realize that Rolls-Royce does engine? Do they care even when they enter an aircraft what engine is attached on the wings? No, but honestly.
Yeah. Honestly, when I first got the job, and I think it's happened almost daily ever since, I've been asked, do I get a company car? So I think it kind of answers your question. I don't think by and large, people don't particularly know unless they're av geeks. I don't think they need to know either particularly.
Yeah.
But I want them to know. Because I think as you've seen today, there's some spectacular technology that is helping them move from point A to point B safely. and efficiently. And I think that really, really matters.
Yeah, it does. But so, would you say you have no brand recognition with the traveling public?
I think we do have some brand recognition. I do think that.
Yeah.
But I think the spread that we have, the footprint that we have, and the impact that we have on people's journeys day in, day out, is not well known, not well understood. And for me, having looked inside Rolls-Royce over the last few years, I look at it and think, wow, this is one hell of a story that we tell to the aviation industry, but actually I think there's a brilliant story here to tell to the wider public as well, and particularly the traveling public too.
Yeah, because and the reason I've asked that is because if we take it backwards, we take it from someone entering an aircraft, of course they will see, especially what they do with their stairs, they will see these massive things on the side, so they know there's an engine, of course. They might not know Rolls-Royce, but what they might not realize in that we do a bit is how much your work here impacts us, traveling public, down the line. Like, at the end of the day, you don't see the engine because it just works most of the time. And I say most of the time, pretty much all the time. I mean, have you ever been, you've been working as a flight attendant. Have you ever been impacted by an engine problem that affected your travels?
Yes. Yeah.
Often?
No, not often. It has happened, but not often. You're right. There's definitely been the entire troubleshooting process, which now I have a lot more depth of understanding of how that works. And the sort of classic answer, like, well, we're looking into it. Maintenance is checking something. What does that mean? It's a whole world out there. But no, not often. You just assume that it's going to work.
Yeah, that's why. Right? Same here. I think, and I've not been a flight attendant. You've been in the industry. We'll talk about it a bit later, but I've never been impacted by something like that. Almost never. Or at least I wouldn't have known because the airline would have just told me there's a delay for a few hours, but I don't know what it is. What I say here is that what we saw today is that all the work that you guys do, and it's pretty impressive, actually determines that outcome, that I don't see it not working. And this is maybe why you also sometimes lack the awareness from the traveling public, because it basically always works.
Yeah.
And then as long as it works, you don't really care. It's like, I don't know, if you go in front of you probably have a microwave here, multiple ones. They work. You don't care which brand they are, how they work inside, because they just heat your food. And I'm not here comparing the technology that you guys do here. Please, sorry. But you know what I mean?
Yeah,
There's that. So maybe since we started with that, let's go back. So what do you do here exactly? Because we've seen obviously these factories, but the public hasn't. The guys that we are talking to today, the audience doesn't. So what do you guys do here? For us, it's like you create a baby engine and it grows and it becomes a big engine. But tell us in better words.
Sure, there's a huge amount that goes on here, from both desk-based work or office work, all the way through to manufacturing and assembly of aerospace engines, large aerospace engines. So from the engineering, design, testing and validation, through to what you've seen today around literally growing turbine blades, which is a phrase that people will find confusing, but the crystals grow, and they're made of a single crystal alloy. Growing those turbine blades, machining the turbine blades to their end state, and then assembling the final engines here as well, and then dispatching them to our airline or lease customers.
And you do that all in-house here?
For the high-pressure turbine blade stuff, yes, we do that in-house.
What is a high-pressure turbine blade?
Stefan, you're the turbine guy.
You was confused with the size of them.
Well, let me start. Sort of these days, on all the planes you're going on holiday with, they have a turbofan engine on them.
Yeah.
So what you see typically when you enter the aircraft is the big fan at the front, which is the main component that provides the thrust of the engine. But to drive that big fan at the front, you need to generate some power. Yeah. So inside the engine, which you don't see when you enter the aircraft, is what we call
God.
what we call is the core of the engine. So some of the air that gets sucked in through that front fan,
Yeah.
which then provides the majority of the thrust for the engine. Some of that that air will then get into the core of the engine, where it gets compressed even further. So we are compressing the air by about 50 times the ambient pressure. So you're basically compressing a phone box into the size of a microwave, for instance. Yeah, and then you add some fuel to it, and then you ignite the fuel. And then once you ignite the fuel, then that energy that gets released, then you enter the various different turbine stages to then extract the energy out of that one to turn that thermal energy into motion. So you then turn the turbine turns, that then drives a compressor that can then compress the air. The next stage turbine drives another compressor stage, and the last turbine stage is they drive the fan at the front to then provide the thrust. So all the turbine blades are doing, there are multiple stages in the engine, they're all extracting energy out of that main gas stream to drive the whole machinery. It's a bit like a normal reciprocating engine. Yeah, you put fuel in, you light it, and you extract the energy out of that thermal explosion
You
you
make
created.
it sound so simple, yet it's like as witchcraft.
In the overall, as a sort of
No, I know, of
cycle,
course.
it's reasonably simple. But yes, there's loads of technology that goes into it that makes it work and makes it work efficiently. Yeah, because the whole purpose is to fly somewhere in the most efficient way. Minimum fuel burn, minimum impact on the environment, minimum noise. That's all what we're striving for, to get a most efficient engine out of it. Yeah.
One of the biggest things we saw today was dealing with heat management.
Mhm.
Maybe you can just tell us about, how much temperatures are we dealing with inside the engine?
Within that engine, so once we've ignited the fuel and the combustion takes place, we're having gas temperatures reaching well over 2,000 degrees centigrade. So that's half the temperature of the surface of the sun. So pretty toasty.
Okay.
Yeah.
So about two suns on either side of the engine.
That's right. Yeah.
Okay.
Yeah. So,
Good.
yeah. So that obviously that thermal energy needs to be managed. Yeah. So we need to make sure our components start with a alloy that is very temperature resistant.
Yeah.
So by the time we enter the turbine stages, the temperature has dropped already, but it's still well in excess of 1,500 degrees centigrade. Yeah. So we're still many hundred degrees above the melting point of our metal we're using, even though what you've seen this morning is the most advanced single crystal nickel super alloy that has got really high strength, but it still melt at about 1,200 degrees.
Yeah, so that was for me the most mind-blowing thing. So it's hotter than the actual melting point
Of the metal, yes. Yeah. So
it's witchcraft. That's what I just said.
Yeah. And some of the
It's
processes
science,
are
science, of course.
Yeah. But what you've seen this morning is the turbine blades, when they get manufactured, when they get cast, they are hollow inside.
Yes.
So inside the turbine blades, we've got an array of cooling channels to pump cooling air through the inside of that turbine blade to extract some of that temperature to lower the metal temperature to make it survive. Yeah, that air that we're feeding into the blade, however, needs to have a high pressure, because obviously on the outside of the turbine blade there's quite a high pressure with the hot gas going past.
Yeah.
So the pressure inside the blade needs to be even higher. So the only air we can use for that is we're taking it from the back end of the high pressure compressor, which has been essentially, as I said, compressed 50 times. And by the time you compress the air, it also heats up. So by the time the compressed air is used to cool the blade, that is already 600-700 degrees centigrade warm already. So that's the air we cool the turbine blades with.
The 600 degree
600 degrees centigrade just to cool the blade. Well, it's cooler than 1,500.
Sure.
Yeah. So it's temperature delta is all you need, isn't it? Yeah. Yeah. So that's one big step. So having it's like your radiator at home, just reverse. Yeah. So we got cooler liquid going through the inside to extract the air out. Yeah.
Thank God my radiator doesn't run at 600 degrees though.
It will be a bit toasty. Yeah.
Wow. And so that super alloy, so guys, I don't know, you can find pictures online, but basically you put all these blades around like in a circle, right? And how fast do they rotate?
So a HP turbine stage rotates about 12,000 RPMs, so 12,000 times per minute.
Wow.
Yeah, so that's sort of a typical speed for a high pressure turbine rotor.
Do they
Yeah.
do they go faster in some?
No, that's the HP is the fastest stage, and then
Okay.
further back in the. So we've got 3 shaft engines. So we've got the LP, the low pressure turbine, sort of the big turbine at the end drives the fan at the front. Then there's intermediate stage compressor and turbine. They are spinning at around 8,000 RPM, and then the high pressure in the middle of the engine spins around 12,000 RPM.
And so each blade is individually casted
Yeah.
and then added to.
Assembled in an array into a turbine disc, which then connects to the compressor shaft to transfer the load into the compressor to drive the compressor.
I will say before we go on that what I was impressed with this morning, there was 2 things. First, I didn't realize, to be frankly honest with you, I didn't realize we were manufacturing this in the UK. I had somehow this thought that, like most Western countries, our industrial might has left and right in other countries, cheaper countries, and I'm not saying all of it, but I thought, and especially with the global operations in aviation, I thought a lot of it was outsourced to multiple posts, and then here was mostly our headquarters. I'm really sorry, Ben, that I thought that before you invited us to be here. So I was very happy to see the factory this morning. But the second thing for me that was, and I think we said that, talked about it earlier just before recording, the number of people. I had assumed that, again, maybe a mistake, that there would be robots everywhere. That's just like, and like you see in, car factories, even though in car factories you have humans as well, but there was a lot of human involved. We've seen from the process to the creation to the actual quality control assessment. And it gave out, and that's me being the romantic here maybe, but I gave out this almost a physicality of craft. Like it was not only something like of course it's a science, and of course it's an industry. Of course you do this at scale because you sell so many engines, and you need to also create spare parts. But I entered, the first thought I had when I entered the factory was like, oh wow, it feels like there's people really creating, like, watchmaking. There are people like doing precise work without feeling either to be like, repetitive work like we've seen like back centuries ago, but like something that was, that gave me, it made me smile, basically. I was like, wow, this is so cool that it exists. And sorry, I keep babbling. That's my specialty, I know, but everybody seemed to be very happy and proud. We spoke, thanks to you guys, we spoke to a lot of people, just on the floor, and there was a pride that I rarely see in an office at Ironman's usually. I don't know. Maybe you just toured it the right way. I don't know, but
no, I think first point is that what we saw today was the production and machining of one component in an engine.
Of course, yeah.
It's a global operation, and we have a similar level of expertise in Singapore, in Berlin, Indianapolis, and also elsewhere around the UK. So we have that type of, it's a global operation.
Yeah.
In terms of the people, they really, really care. And you could see, I don't have to tell you that because you can tell from your experiences today, that they really, really care about what they do. And I think that the level of human ingenuity and expertise that you can see in the way the components today are crafted is definitely replicated in our other areas around the world. Okay. You've worked in it for so long. I mean, how do you feel about it all?
Yeah, I think for me the key thing is, and a lot of other my colleagues, it's a very challenging job, and it's very interesting. But that's what makes it so good.
Yeah,
and is something where you sort of like, you go to work, and you go to work because you enjoy what you're doing. Yeah, and it's always something that you learn something new. We're always trying to improve our components, our products, to make it better. And that's what makes it such a great place to work at. And you see that across the patch, within all departments. And the skill necessary to do some of these components is so high that some of these components, like turbine blades, we cannot outsource to low-cost countries because the skill level isn't there, and you need to have that level of expertise. To some degree, I said early on, witchcraft, to some degree, is a lot of it is tacit knowledge that you build up over years and years to be able to refine the process to get a good output and get a quality output from it. And you can't just quickly move that onto a low-cost country, and 5 minutes later you've got another production
Of
facility
course
there.
not.
Yeah,
That was not my point, actually.
Yeah.
Right?
The human touch is reassuring.
Yeah.
You know,
That's
to
what
see
I-
that humans
exactly.
are, I mean, listening all the stats about which is very microscopic tolerance for what is a pass or a fail on the components, and having the fact that a human with a brain is doing that, you know, is fantastic to hear. That is still part of the process, and it sounds like it's going to be there forever.
Augmented human, because we've seen, there's
Yeah.
a
That's it.
lot of use of,
And there are automations that we have in other factories, and it's automation is not something you can avoid. So it's more a case of how do you do it. But I think what we've seen today is those processes where they're kind of at their start of, or close to the start of their manufacturing journey, and that process needs to be worked through by experts to perfect it. And it's the sort of thing that we might do here in Derby, but then we might draw on our digital centre of excellence in India to help us figure out, well, what does the data tell us, and how can we automate it, and how can we perfect it, and how can we smooth it out, and all that sort of stuff. So there's a lot of ways that manufacturing process can go, but what we saw today is absolutely right. It's the human hands-on approach to creating these incredible pieces of kit that are, like you say, very small but extremely powerful and extremely strong.
but even for the casting facilities, we have actually a more modern facility in the UK,
Mhm.
near Rotherham, where again it's a lot more automation there, so
Yeah,
a
it was
lot
mentioned,
more
yeah.
robots.
For more scale.
That's when once you're having a settled design that you're going to mass production with, then you can use the robotized facilities to essentially scale up and increase the volume and everything. But at the beginning, especially at the beginning of the journey, when we're still finding things out, we're testing things go wrong, we're tweaking the design to redo it. That's where you need the flexibility, and that's where the human touch is absolutely important, to be able to have a quick change to say, oh, we can try something different. Yeah,
How many engines do you produce here? It's quite a lot.
In terms of output, it's several hundred a year
Yes,
out of the door.
yeah.
So, but that's kind of like the end point of components and modules coming to the UK from around the world. So the supply chain is complex and international. But yeah, it's above one a day, far more than one a day actually. So it's quite a busy operation.
You said faster, better, or I'll say cheaper. I mean, you try to be as optimized as you can, because at the end of the day, you're selling those to clients, so airlines, that sometimes have a choice, depending on, of course, they have a choice of whether or not they buy Airbus or Boeing, and sometimes they will choose your engine. And I think, for context for the audience, because some of them actually don't know, where do we find your Rolls-Royce engines today? I mean, they are aircraft that in the past, the 380, for instance, was one of the options. I think you had 50-50 market share. But currently, what aircraft, where do I find a Rolls-Royce? I know the answer, but rather you tell me.
No, it's fine. Well, I mean, in terms of the civil aerospace business, a lot of our engines they're all wide-body engines to start with, and then there's a portion of the market that's also business jet engines. But for today,
this is how you fly every day.
yeah,
right?
of course. After I got out my car, the most common you'll see is around the Trent XWB, the Trent 7000 and the Trent 1000. They're our modern fleet of Trent engines. So the Trent 1000 is on 787, Boeing 787. Trent 7000's on the A330neo, the Airbus A330neo, and the XWBs. There are 3 variants now. There's the 84, the XWB 84, which is on the Airbus A350-900. There's the 84 EP, which is for that aircraft also, which was new into service this year. And there is the Trent XWB 97, which is on the Airbus A350-1000. And so they're the sort of the biggest and most common engines that you'll see of ours on wide body aircraft.
I just flown by the way, guys, you know that we both are jet lagged on this side of the table. I've flown from New York, but it was like 36 hours ago, so I'm fine. But I flown with Lufthansa on a 350, so it was, I don't know which one of the two. It was a 900, but since you said there's two engines, I wouldn't know which one.
It'll be an 84.
Dash 84, yeah.
And you've flown from Canada just for this. On a 777, though, there's I don't think, was it on 777 you came here?
It was 777.
Yes.
Yeah.
So I don't think it was a Rolls-Royce engine. But but that's on BA, I'm pretty sure I've seen that Rolls-Royce, your famous logo,
Yes.
is always there. When I was flying Lufthansa back from New York to Munich, I was like looking, because I knew what was coming here. I was looking, I don't think I've seen it. I mean, of course, I didn't take the stairs. We took a bridge, and it was nighttime. But I was looking at, and I was sat next to the engine, by the way. So I was like, where is double R, the famous? So is it do the airline have a choice whether or not they have to display that it's a Rolls-Royce engine or not?
Yeah, it's their engine. I mean,
Okay.
they can choose what to put on it. They can choose their design for it. Their decals that will go on it. So yeah, they don't have to display the badge. We'd love it if they all displayed the badge and everyone knew that we were powering them on their journey. But no, it's not compulsory at all.
It's not compulsory. So you want to? Because do you want to?
No, it just kind of took me back, a memory flash. When you talk about the logo, for those of you that have listened to me before, I worked for British Airways on the ground in the Calgary base, and we had the 777-200s, and we'd have the two variants coming in, one with the massive, the GE engine, the one that everyone saw was big.
Not heard of them.
No, right. And then the other one was one of the Rolls-Royce engines. Yeah. And you could see a different mood from the pilots that would come off. From the two types, because from what I understood in talking to them, I think they just preferred the Rolls-Royce actually in general, because it was faster, more efficient, something about that, and they were all like, yeah, we had the roller today.
Oh, is that right?
Yeah, that was kind of like the code.
Do you know what?
Right.
Like that connection with pilots, I think's really, really crucial. And we have our own pilot team in Rolls-Royce who are ex-airline pilots or ex-military pilots who work with airline pilots now, both in terms of, helping us explain the engines to potential customers, but also to help pilots understand what they can do to contribute to increasing the durability and the efficiency of the engines in terms of how they fly. It's not quite as crude as, do they have a heavy right foot or not? But there are aspects of how an aircraft fly that are particular to individual pilots, and the degree to which they have that flight behavior does impact on the engine, understandably, and it can actually help improve the durability of the engine and increase the number of cycles that you might expect to get out of one. So the pilot connection is really, really strong.
But that durability, actually, because this is where I was going with this. Where do we find these engines? Because customers have a choice. In the case of the Dreamliner, the 787, they have a choice whether or not to go with you. So you need to convince them, right? It's part of your job. You need to sell them the idea of, it's not only because Rolls-Royce, has an heritage name and everybody knows them. Although, like you said, do you have a company car? But so what's your current? I mean, again, for a passenger perspective, if I go back to what we said at the start, at the top of the show, we care here, you, Vinod, and me, but most people do not, or at least maybe they, not that they don't care, they do not know. They might even think that the engine is Airbus and the other engine is Boeing. That's as far as they go. And I'm not here being condescending. I'm just saying,
No.
it's like
That's
me.
the perception.
Do I know what engine do I have? What do the rental today? Kia. I don't know what engine is there. I assume it's a Kia. Maybe it's actually a consortium with somebody else, and it's I don't know. A Volkswagen engine. I have no idea. So in that same sense, they don't. But you have to convince the airline. So the airline probably wants faster, better, cheaper. I mean, the usual. So they want to have something that is cheaper to operate than what they previously had, simply also for economical reasons, for environmental reasons, because they might have to deal with noise abatement. We know that over the big cities, etc. But there's also a connection with the passenger, because the passenger wants an aircraft that is there when it says on my app that it's going to be there. And that's where sometimes since you mentioned the word durability, if there's a problem with the engine, do we know if it's a problem with the engine? Sometimes we don't because the airline doesn't tell us, but that's where it gets back to you. Is it on you when you have a problem with the engine? How does it work with the airline?
There are a few facets I think that airlines tell us, and we know that they care about: efficiency, reliability, and durability. Efficiencies around fuel costs, but also environmental impact as well. Reliability is around dispatch time, and you'll be, from your airline experience, you'll know the importance of on-time performance, OTP.
Yep.
And I think the last one is around, the kind of long view of fleet health. When do I know, when do I expect, and when do I plan for this particular engine to come off wing and go in for a heavy check and maintenance? And how predictable is all that stuff? Because no one likes surprises. And so we want to be on it all the time in terms of those three factors, because that's what our customers care about and that's what passengers care about.
And also, sorry, because I know because of your role, you know that, but because we said nobody cares, but we hear your name sometimes when something bad happens, because the airline will say, oh, the Rolls-Royce engines have an issue, we needed to ground the fleet. And that's where suddenly people might hear of your name. It's sad for you on your perspective as a comms guy, because you're like, it's because the airline puts it on us. But I mean, it also matters to you that durability doesn't only matter for the airline, but also to you, because you want them to be happy, but you don't want to deal with bad press either, I guess.
No, that's true. But and in some cases that has been the case in terms of the durability of engines. And we're investing around £1 billion between now and 2027 or 2024, 2027 in looking at that challenge. So that involves, like we saw this morning, how can we make those high pressure turbine blades, which are the hardest working part of the engine, last longer? How can we improve the performance of that part of the engine when it comes into contact with sand or dust in those types of environments? How can we improve the predictability of maintenance schedules so that the planning for airlines is as smooth as possible? So, and we're making real progress with that. I think that billion investment is starting to create tangible outcomes for customers. So just this year, we've seen the XWB-84EP come into service, which was part of that investment. We've seen the certification of the new Trent 1000 high pressure turbine blade, which will double time on wing for those customers. And there's more to come in terms of the Trent 1000 and the Trent 7000's durability in the new year, which will add up to a further 30% of what we call time on wing.
Time on wing means?
Time on wing means it's the duration that an engine is on wing before it's due to come off for scheduled maintenance.
Oh, there you go.
So it's availability, basically.
Yeah.
And so there's that. There's those types of things that are starting to get into the fleets now, and to sort of smooth out those, I guess, fleet profiles that can be buffeted by, earlier than expected maintenance or earlier than expected engines coming off the wing to replace those parts that have worn quicker than we expected.
Because when you sell an engine to an airline, do you promise? Do you tell them it's going to be that amount of time before? And if you don't respect that, is that on you? How does that work? So
we
I don't know.
So we have agreements where
I'm sorry to interrupt. I'll be just shouting at the car dealer, but there's no promise that my car would, if the car stops crapping out earlier than I thought, I would be. But there's no. I'm guessing it's different here. I'm guessing you have contracts that actually say.
Yeah, so we have agreements with airlines where we are paid when the engine flies. So that's called engine flying hours.
So that's how the time is measured then.
Yeah, so there's an incentive for us to have engines that are always flying, because not only does the airline have stable plans and stable revenue, but we also have revenue from when they fly too. So
hold on, explain that again. So you're telling me that you're not being paid unless the engine is in the air and flies? Well,
we sell the engine, but also our revenue by and large is from when the engine is flying. So it's in everyone's interests that we have efficient, reliable, and durable engines, because
because you
everyone's
win
happy.
as well.
It's a win-win, right?
Yeah. And so you want that to go on for years.
Yeah, and so
Right?
these engines have 20, 30-year lifespans at least. So it's that's the structure of how the civil aerospace business operates.
I would have not known. Maybe I'm just an idiot, but I didn't realize. It's like as if my car dealer would tell me, "Hey, I'm going to get a $1 every time you're in the car actually driving." I didn't know that existed. So
Yeah.
I mean, it's clearly an incentive for you then as well, because you're not making money if.
Correct.
Wow, what happened during COVID then?
So we had a tough time during COVID. That was really, really impactful for the business. And there was a whole load of finance measures that were put in place to help the business survive through that. But since COVID and since the return of how we measure it, which is engine flying hours, the growth is now the equivalent to what it was before COVID in 2019, and we expect it to go between 110, 115% in this year of 2019 hours. So it's kind of the business is in a place it's never been before in terms of how we're transforming with a new chief executive and a program that sort of orientates us to focus really, really hard on what customers want, what customers need, and delivering that relentlessly. And at the same time, we're looking at a growth in engine flying hours and a growth in travel demand that we have to meet. So we've got to be prepared for that. We've got to be prepared in terms of the products that we're sending out the door, the components that we're making to go into engines that are already in the fleet, and also how we cope with that maintenance, repair and overhaul activity and that capacity that's required between now and 2030. So we're also investing a lot of money in expanding our MRO capacity, because then we know that when we have new upgraded components that are more durable, that we get them into the fleet to existing customers already. Plus, also we can cope with the increased requirements from just general travel growth. That means that there are more engines out there and more engines that will need their off-wing checks in MRO facilities around the world.
We could kind of circling back on the people that work here, and obviously the workplace culture stems from how management kind of lays things out. We're talking about the life of these engines, 20, 30 years. Like, this is generations of people. I mean, even just the whole accounting side of that, of getting paid by how long the engine's flying, like, that spreadsheet's going to go on from one person to another and another and another, within every decade or so. And the number of people that have the touch points on it, it's fascinating. And you kind of see, just in the brief time we've been here, just the sheer vast array of people and what they focus on, and that they enjoy it. It's part of the big hog, right?
I mean, I used to work in nuclear, and those contracts are 150 years.
When Ben, like just earlier, like we were walking, I think here, and he says, "Yeah, I was working in nuclear." I'm like, "What?"
Yeah, so I used to work in the commercial in nuclear, in the commercial side of nuclear fuel, nuclear waste.
You were also working for Thomas Cook, so how? The guy worked for Thomas Cook in nuclear. I mean,
didn't you work for nuclear?
So those contracts are 150 years. So a 30-year contracts, that's
oh, wow.
that's almost short term for me. No, but I think what you see is, though, you've got a long-term view of the business, and I think all advanced technology businesses have that long-term picture, particularly when it comes to the development of new technologies. But also you see definitely we experience now, I think, is a day-to-day intensity around, okay, what can we do better? What can we do simpler? What can we do faster? There's absolutely that kind of bite in day-to-day. It is not an armchair ride over 30 years or so.
Yeah, we mentioned, we'll go to the actual engines and how to make them better. And I want also to mention, because you mentioned dusts, we'll talk about it. Yeah. But before we met, earlier on when we were walking, I was like, of course, I need to ask the usual questions, because we are here, this is how it works. And I was like, how do I talk about your management? Because this is something I'm like, will people be interested in talking upper management in our type of podcast, which but you mentioned something that I really actually appreciate. You mentioned that your new CEO, how long has he been a CEO now? You said
since 2023.
2023. And it's maybe because I'm partial to that, but you mentioned that he seemed to be a very go realistic. We need to, pardon my French, get shit done, get money in, and get realistic. and maybe it was needed after COVID. I don't know. I wasn't here. I don't work here, obviously, but I kind of, I didn't know that was a fact, but I kind of like it, to be honest with you. So.
Yeah, I could characterize it as, there was a survival phase for Rolls-Royce, which I think culminated in COVID and coming out of COVID.
Survival, so that was that bad?
Yeah, it was really, really significant.
Oh.
And now we're in a new chapter for the business. It's 120 years old next year, Rolls-Royce.
Wow.
And the phase we're in now is, and that our chief exec has brought in, is one that's, you could probably kind of sum it up as there's an awful lot of transparency around what's going on in the business, who's accountable for what, how do we manage the performance of the business as a whole, and how do we really focus on the things that matter. And I think that's not survival behaviors, that's growth behaviors, that's a growth mindset. And that's absolutely where we are now. And above all, that's kind of, what do our customers want? What do they need? And how do we get it to them as quickly as possible? And keep on listening. So that's kind of where we are now. I think, the share price performance probably is the best depiction of where we've come. But Rolls-Royce is a big business. It does lots of different things. It does more than just civil aerospace engines. It does a lot of military engines as well. It provides a huge amount of power, backup power to critical infrastructure around the world. The biggest growth area for that currently being data centers, and that's provided by big diesel backup engines, which we do.
Okay, wow, didn't know that.
Yeah, so there's and on the horizon is the prospect of small factory-built nuclear power stations, which are those what are called small modular reactors. So there's a lot going on in the business, but it's driven by that intensity of what really matters, what's going to be profitable, and what do our customers want.
So what do you customers want? Going back to engines, let's put it out, because there's been, and we were talking about it, that I didn't know if I wanted to talk about it, but since you were very open about it, you're very, guys, you don't realize it. I hadn't met you before today. I mean, we exchanged, of course, on a Zoom call before doing this. And I love the fact that you're so open about all of this, because it's always, when you're invited like this, you're like, on eggs, you don't want to be too, but there was a bit of, controversy is maybe not the right word, or maybe you'd call it controversy, but you mentioned dust, sand. There was an accelerated degradation. I don't know if I'm talking under your control, because I might not have the right words.
No, that's fine.
On the turbine of the, was it the ones on the 350, right?
350-1000. So
1000,
the specific challenge we had from one of our customers was around the durability of the Trent XWB-97, which powers the powers the Airbus A350-1000.
What do you mean by durability? So the expected lifespan of a turbine, or
I mean, Stefan will cover the technical stuff, but because I can't. But the long and the short of it is, we expect, when we design a component, we expect it to last X number of cycles, which is taxi, takeoff, cruise, land, taxi, and we predict that it will last a particular number of cycles in certain flying environments. And then what's happened with that in the past is that component has not lasted as long as we predicted it would. And so therefore it needs to come in for maintenance. It needs to have those components replaced more often, which disrupts fleet planning for the airlines. So our job is to go, okay, well, we've got this challenge, and we knew we had that challenge anyway. Because we did an awful lot of work on dust ingestion, particularly around 2010 and the Icelandic volcano, which grounded 100,000 flights. And
we're not gonna attempt to tell the name of that volcano, the Schwinzels, because
and we took that challenge and we go, well, what do we know about how engines perform, and what do we know about the innards of engines that are impacted by hot components coming into contact with dust. And we solved that challenge. We solved that for the industry. There's not been a volcanic disruption in terms of aviation of that scale since, because of the work that we did. So we've applied that knowledge forward into flying these engines that are getting hotter and hotter because they need to be more and more efficient. And asked people like Stefan to go, well, what can we do to improve the durability of these really hot, hard-working components that do have a limited life, but how can we extend that life?
So what can we do?
Yeah, and
But maybe tell us also what happened.
So in general, when I mentioned early on, we have the internal cooling system inside the aerofoils. We also have tiny little holes all over the aerofoil surface that eject a tiny bit of air out and provide a cooling film over the external surface of the aerofoil. So that provides an extra insulation to that hot gas that goes around that to stop the blade melting. In addition to that one, we also have a ceramic coating on the surface of that aerofoil to again provide another layer of insulation to that hot gas. The trouble is with that ceramic coating that it doesn't want to expand with the metal underneath it because ceramic is brittle. Because if you drop your plate at home, it'll smash to pieces. Yeah, so ceramic is
as a Greek, I know very well. Sorry.
Yeah. So we have to apply that coating in a way that it actually, rather than being one continuous sheet of ceramic, it's actually loads of tiny little columnar pieces of ceramic that are on that surface, so they've got loads of gaps in between them. So when the metal expands underneath it, the gaps between the ceramic just increase a little bit. The trouble is all those tiny gaps now. So we are flying in a desert environment, in a dusty environment. All that dust comes through the engine. It gets through that combustion chamber. All that dust is now melting. So so you've got, rather than having particles of dust in there at those temperatures, is melting, and that molten sand, molten dust is then starting to fill those little gaps between the ceramic material, and that then glues them together. So it's like super glue sticking everything together, and then it stops wanting to expand again. And that's when that coating fails, and when the coating fails, then the degradation of the part accelerates. So we have to extend that life for the coating to survive. And in the same way with the cooling holes, that sand can also block our cooling holes up. So again, we need to stop all these cooling holes blocking with the sand at different temperatures. If it's really hot, it's really, really runny, and it's really getting into those tiny gaps of the coating. If it's slightly cooler, the sand is not liquid, it's more like sort of toffee texture, so it's really gooey, really sticky, and it likes to stick to the cooling holes and then blocks the cooling holes, and that doesn't help the life of the blade either. So we need to prevent those environmental attacks onto our parts and extend the life of our components to make them last longer in these harsh environments.
So do you have a plan?
Yes, so there's a number of ways we can do that. So one way is to cool more efficiently. So to use the cooling air we've got in a more efficient way to drop the temperatures of everything. So if we can make use of the same amount of cooling air, but use it more efficiently, we're dropping all the temperatures. So that will help. Yeah. The next thing is that, okay, so we've cooled it as well as we can. Then what other coatings can we apply that can cope with some of these environmental attacks a bit better? So we are now onto Ben mentioned on the XWB-97, where we had the life problems, the lower time on wing. We have applied another coating layer that can cope with the attack of that dust, molten sand better, provides an additional layer of protection, and that extends the life on wing. And we're also working on another improvement where we're improving the cooling system and looking at different coatings. And we've got further research programs going on to look at further enhancement of the coating. So we need to look ahead, not just what happens next year, but what happens in 4, 5, 6 years' time, because engine temperatures only go one way. They're going to go up. So everything, to get a more thermally efficient engine, temperatures will go up. So we need to be able to cope with that, and therefore need to have constantly bringing new technology on board to make us survive in these kind of environments.
I think what you said there is one of the things really important to get across is that these are long-term programs, right, over many, many years. We don't wait to the end of the program to insert new improved technologies into existing engines or new production engines. With the Dash 97, there's 3 phases of improvements. 1 and 2 are already in engines in the fleet, and they're already improving durability by 60%. And we've got an incredible, unique set of data from our operations with that engine in Qatar and also with Etihad as well, that allows us to recreate the exact conditions in our test facilities. so that when we're testing these improvements that are still to come, the third phase, we're doing it with unprecedented accuracy. We've even made our own dust with the help of the University of Manchester to sprinkle into the engines that exactly replicates the dust that you find in the Middle East.
Oh, wow.
So when we're putting these things in place, because of our unique position of operating those engines in that environment and capturing all that data from both real-time monitoring of the engines, but also inspection of those engines and servicing of those engines over many years, we can pile that all into our sort of replicated environment in our test beds and make sure that when we're testing it, we're actually testing it correctly, not testing it falsely and then, causing another problem down the line. So if it goes out into the fleet, having gone through that process, then we know it's going to work.
I find it fascinating here, the timeline stretch. We're talking about airlines, customers putting in orders for aircraft 20 years out, 15, 20 years for delivery on a product that is now in front of them at an air show, in a brochure, however they get it. And trying to be able to forecast that and merge that with the engineering side of this is the metal, this is what we have today. How does that kind of mesh up? Because, you're looking at something that'll last 4 or 5 years, and climate change, all this kind of comes into play. I'm just curious how that all kind of bundles together in terms of the forecasting of what the demand's going to be.
Well, I think there's a few aspects. There's the technology development stuff, which Stefan's going to be all over, which has very long life cycles, but iterative developments as well. And then there's the manufacturing side of it, which is around the physicality of what slot, in what day, in what year, in what month. Do I have to secure to get my engine for the aircraft?
Yeah, you mentioned that.
So
your delivery can be
that was
so precise. Right?
Yeah.
We're both blown away by that.
Yeah, because when we read about this airline has ordered this amount of aircraft, like you were just now at the Dubai Air Show, so you've heard all these, right? And for me, it was like, in 2029, like maybe in March or in April. No, you're telling me that the engine is already slotted like in an afternoon in 4 years.
Yeah, we'll program down to the day, probably about 5 or 6 years out.
Can you tell that to car dealers? Actually, I don't own a car, but I hear all my friends complaining that their cars are never delivered on time.
And that's based on the engine that they're buying today, that they're signing on for today.
Yeah.
So if a new variant comes out, then that would have to be revisited potentially.
Yeah, possibly. I mean, one of the things that I think people like about doing business with us is that we'll get them new and improved technologies when it's available. So there's always a conversation to be had about what more can we do, what's new on the block, stuff that Stefan will work on now that might come into production and be productionized and into manufacturing in 5, 6, 7 years time. It might not be engine specific. It might go across several different types of engines, and we always learn, what performs well on one engine. How can we replicate that in some form, preferably exactly, in another type of engine? So there's an awful lot of cross thinking that goes on across fleets, because what you learn in one area in one set of conditions might well apply to a customer's benefit, in a different airline in another part of the world.
Mm. Do you work on all engines?
So my job role is essentially across the board, nothing specific. But obviously, every technology gets specifically developed for one product. But then, as Ben said, we would then roll it out over other products if it applies and if it provides a benefit. Yeah. So it's what I need to do is look across the portfolio of products we've got to say, what is the most important problem we need to solve? So where do we put our effort in? Because we need to earn the right to put money into research, isn't it? Without money, we can't do research, isn't it? And then, but whatever research budget we've got, again, we need to then select which technology has the most promise and what gives us the biggest benefit out of it. Yeah, and that's the one we would need to then focus on. And
you make that call, or
I'm part of the team making that call. Yeah, I don't know it all myself.
Yeah. Of course not, I'm sure. So I'll go back, but because you raised something that I never thought I should have thought about. Of course, when an airline puts an order, so they choose the engines at that point. Obviously, the who's bringing the engine. But if I go even further back, when there's a dance with the manufacturer as well. When Airbus decides to create the 350, well, they come knock on your door, or they come knock on all the competitors. I'm not asking here to tell you the story about a specific line, but there's also there's probably, and you don't have to tell us, of course, because probably all that is NDA, but there's probably research about future aircrafts by all the manufacturers, including the Embraers and all these guys. I know you don't do narrow bodies, but maybe you'll do back. You used to do that. You used to have
do that.
narrow bodies back in the day, But meaning, how does that dance work? Just in general, do you go to them like, hey, you have this great engine, you could create an aircraft around it, or is it mostly to you?
So I'm not sure how orderly
Yeah.
it is, because I think the best way to summarize it is we're talking to everybody all the time, and we're all looking for opportunities in the marketplace all the time, and so I think that we have great relationships with Boeing and Airbus. We work very closely with them. So it's almost like the conversation doesn't start. It's just part of our relationship that we discuss how we're going to move the business forward. Where's technology taking us? What's the pathways that lie ahead for us to improve and get better and give customers more of what they want? So I'm not sure it's necessarily a specific conversation.
Yeah.
It's probably more organic than that, up to a point, and then of course you get into agreements and so on and so forth,
course,
and then it's different.
Plus, they need to know. I mean, you're going to maybe tell us a little bit about, without telling trade secret, but where's the future look like? The Boeing or an Airbus also need to know what you're able to do, because they need to build an aircraft, but also they cannot build an aircraft when they cannot power, right? If there was like a super stretched version of a 380, which won't happen, they would need the power to do that. Or let's even say they would. I love the 380 for context. I'm sad that it's not in production anymore. If it had too big, it would be a twin, which imagine the size of the engine. So that's impossible probably. But if Airbus wanted to do that, they need to talk to people. Is it actually physically possible before they actually go into production? So what is maybe... You said the engines need to be hotter and hotter to be more efficient. You said that twice, but for me, it doesn't sound logical.
Okay. Well, the first requirement that comes from with the discussion with the airframers is sort of what size of engine you need. It's the amount of thrust is the fundamental starting point.
Yes.
How big is the aircraft? What's the payload? How far do I want to fly? So what kind of thrust do I need to take off? Yeah, and do I have 2 engines or 4 engines? So that decides the first parameter. Say I need to have, like in the case of the XWB-84, about 80,000 pound thrust to power that aircraft. To create that amount of thrust, then we basically work out, okay, how big does a fan need to be, and how big does the core of the engine need to be able to create that thrust and create it efficiently. And we can create more thrust efficiently if we have a bigger fan. The bigger the fan is, the bigger the bypass ratio is, the more thrust we can generate efficiently. There will be constraints in terms of if you have a wing, an engine under wing. It's not a matter of space. If you want to make it bigger and bigger, you sort of scrape it on the ground, isn't it? So you need to have really, really high undercarriage and stuff like that. So there will be size limitations in terms of how far you can go there. Yeah. But in general, bigger fan is better. But also from the internal core of the engine, the efficiency improves. The thermal efficiency improves either by running the engine hotter, or by compressing the air more.
Okay.
Both of which will make either the gas temperature around the turbine blade hotter, or make the cooling air that we're feeding into the blade hotter. Yeah. So both parameters that are really the key drivers for thermal efficiency of the engine to get the most efficient engine out of the door are challenges for the components to survive in those kind of environment. So that's why if we want to have more efficient engine, if the next generation engines, we want to get our fuel burn another several percent down relative to today's generation engine. The only way to generate that is to either have more propulsive efficiency, i.e. bigger fan, or more thermal efficiency to get the core of the engine to work better at a given fuel burn. So that's the technology we need to develop to make sure that we can achieve those kind of targets. That for a new application, the customer wants a more efficient engine, wants to fly further, wants to fly quieter to comply with all the regulations, and wants to be more environmentally friendly. All those things are sort of requirements we need to consider when we design our engines all the way down. And all those high-level requirements get then broken down into subsystem component requirements. So everybody who works on those parts knows what they need to do. Yeah, because it's no point saying, oh yeah, you need to design a new turbine blade. Against what requirements, isn't it? So without having the requirements, but you need to have the engine requirements first to then break them down at component level. And there will be interactions and iterations saying, oh yeah, these are the engine requirements that the customer wants. And it's like, okay, that's beyond the laws of physics, so we can't do that. We try, but we don't always manage.
Do you have often customers asking you stuff that's beyond the laws of physics, or does it happen?
Well, at the end of the day, as a customer, they sort of come up with requirements saying, okay, we want to have that cost, that fuel burn, that weight of the engine. And you're saying, okay, all those three wishes can't happen at the same time. So we need to trade some things off. But that's the opening starting point in those negotiations. And that's part and parcel of it. Yeah. But it's only if you're asking for that, that's when your technology gets pushed and you're developing the extra next step you need for the efficiency to improve.
All of this that we're talking about, I just kind of think of something that one of the people that we interacted with said, we will focus also on the here and now. And when I'm thinking of, we're talking about the pilots and the crew and the passengers, none of this passes through their thought pattern because they're thinking of right now getting this plane off the ground. And another part of the our day spent here was seeing the support that goes into the engines that are flying.
That's
putting words to what we saw was just it's difficult, but maybe you can just explain kind of that support system that's there.
Yeah, sure. So
that big screen and the team behind it.
It's a cool screen.
I was in Mission Impossible watching like a war center. No,
I think they turned the holograms off because we were there.
Yeah.
Well, I think so. Around every engine, there's a support system from Rolls-Royce, and I think this goes back to our model of engine flying hours and making sure that engine availability for customers is paramount, because then they have their intact flying schedule and we have our intact revenue. And so what we have is a team of people who sit downstairs in this building, who have for 20 years this year been running what's called engine health monitoring and services capability center downstairs. And they are there to help with the here and now, as you say, of airline customer requirements when it comes to the engines that they have on wing, fired up and ready to go, or during turnaround. And so what I could best describe it as kind of like is flight tracking on steroids, right?
Yes.
So not only is it about not only is it about all the stuff that as av geeks you and I would look at on our various apps, but
in our perfect world we would have that in our houses
exactly
on the wall at all
that
times.
size of the screen.
Exactly. And so what we have overlaid on top of that is all of the data that we receive in real time from the engines as they're operating. And that's
is insane.
Yeah.
I thought that you had some insight, but you have clearly a view of all the engines currently in the air.
Yes.
With data real time.
Yes.
Almost real time. Depends on the data, I guess.
Yeah, I mean it varies, but it's for the purposes of this conversation, it's around about 3,000 engines in the air at a single time that we're monitoring, and each one of those is around about 25 to 30 sensors which are feeding back data to us all the time. Now those the algorithms that consume that data know what normal is, and so when they detect something that's not normal or outside of an envelope of acceptable limits or approaching that, then they raise an alert, and then that allows one of our engineers to look into it more closely. What we've done this year as part of the upgrade to that service is we also fold in an awful lot of not literally environmental data, but it's stuff that's happening around the world, around airports where our customers are operating, that could impact their operations. And if we have, for example, a call from an airline that's got an aircraft on turnaround, then we can help them solve with a technical issue. Then we can help them solve that technical issue and kind of keep their flying schedule as intact as possible. And not doing that has a customer impact for us, for the airline, but also a passenger impact as well. So we want that to be really, really slick, and it is. The other thing that's cool about it is that because of the degree of, I guess, almost a high definition view inside the engine as it's operating through that sensor suite, we can often detect potential problems before airline customers are aware or pilots are aware.
It's amazing.
Yeah, that's
before
the
the
great
pilots.
part.
Yeah. Quite possibly. So
We had an example earlier. We don't have to talk about it, but before the pilot is even aware, you know that maybe something could be starting to go wrong.
So do we detect above normal oil consumption, or is there a slightly raised level of vibration or whatever it is in whichever part of the engine? We can detect that, and we can put measures in place while an aircraft is in flight to meet it at the other end and correct that issue or help the airline correct that issue. Hopefully within the time of turnaround, but if not, keeping that any delay or disruption to a minimum. So I think the best way to characterize it is that if you're sat on an aircraft and you look to the right and there's a Rolls-Royce engine there's a team of about 70 to 80 people sat there with you remotely, making sure that that engine works perfectly and that you're going to get to your destination. There's that many people kind of on call all the time, 24/7, to make sure that flight happens, and that there's a whole host of reasons why a flight might get delayed. Our responsibility is to help airlines resolve any engine gremlins that might be occurring.
Yeah, and that impacts actually the traveling public, because we come back to what we said earlier in the show. I'm giving a delay. I don't know why. They're not going to explain. I mean, they say technical, they will not explain us exactly what happened, which is fair enough. I'm not asking them to do so, like the airline when they announce a delay. But clearly the fact that you can be, because we've had certain scenarios, actual guys, by the way, they were not only virtual scenarios, they were showing us live on screen what was happening. I'm not going to say, of course, there was like two airlines that something was happening and you could see the process. And you can clearly think that when let's say I would be in that city where that aircraft is, I don't want to give any hint, that's why I'm not talking, but that could reduce the delay. Yep. I mean, and in here, it feels, now that I've seen, totally logical that you would do that. But the first time I saw that screen, I was like, what is happening here? But it feels, especially now that you had it, that you have also this incentive for being paid as long as the if the engine is in the air.
Yeah.
So of course for you also have a disincentive to have it like having a longer repair or no longer maintenance, because then of course you're not getting paid. I honestly didn't know that even existed. I thought so.
Yeah, I mean you're right. I mean the number one thing is that when we're receiving requests for support on engines, is that the engine is maintained and fixed properly. And so there's no conflict there. But the other thing is that it's the degree of support that we think customers expect and probably have a right to expect, and passengers should have a right to expect, that they've got this wraparound care from Rolls-Royce that they don't necessarily have to see, but they can know that it's there.
So the data, two questions about the data. Sorry.
No, it's fine.
One is for you, but maybe the first one is just a detail, but what was the name of the gentleman that we met earlier? Jim. Because before he even started explaining us, I assumed, wrongly of course, that you would contact, like if you see that in your example, there's an issue forming into the engine, you, of course, this is not how I thought it, but let's put it that way because it's funner. You basically call the pilot, "Hey man, on your right engine, you have an issue." You don't even, but of course, your relationship is with the customer, and the customer is not the pilot, and pilot is God, right? We have a lot of pilots listening, so guys, you are gods, and you are in charge of your aircraft. So you're contacting, I guess, the ops center of the airline, and then they decide what to do with it, I guess.
Yeah, I mean, so every airline will have an operations center, and they'll have their own cohort of people sat together in a room somewhere, probably with the lights out. and we'll liaise directly with them. And then to maintain the chain of command that they have in place for their flights, then they'll deal with the aircraft direct if that's required. It might not be required.
Sometimes with the feedback, did they say, "Oh, we need some more help from you," or something? They said, "You hands off," and say, "Okay, now it's up to you." Is it?
No, I think it depends on the contract. I think it depends on our obligations for a particular customer or not. It can either be a total, resolution or just technical advice or technical authority for a particular for a particular challenge that we've got. But I think, like Jim said, we'll help where we can, and we have this global network of people that are stationed in key points around the world.
Quite a lot, actually.
Yeah, hundreds.
Yeah.
Who are there to help these flights get away on time and help maintain customer schedules. So yeah, it's genuinely a comprehensive wraparound care that we provide.
Yeah. I know guys, I don't want it's very compelling because when you see these examples that they've shown us earlier, and if you think it's logical that you would do this, of course it's not, but that like there might be a repair to be done on an engine, so on an aircraft that is in the air, so you're already preparing the steps to deliver the parts needed at the arrival airport, so that actually gains time for, again, a traveling public that suddenly has maybe a delay of 2 hours instead of 5 hours or more, so that's very useful. But I want to go to the user data. Do you use in your more like looking to the future, is that data that is actually useful?
Yeah, very much so. Yeah. So we need to look at data out of service. What happens in the fleet today is one of the most important pieces of information we can use to make our future product better. So we can absorb all that information, and to some degree, there's so much data out there at the moment. We are really struggling to compute it all. So we are developing more machine learning tools, AI tools, to be able to suck all the information out of their data. We've got so much data available there, but we are not being able to use it all because we haven't got the time to read it all. Yeah. So we need to have some way of translating that data into meaningful data, into a meaningful piece of information that we can then say, okay, these things happening, therefore, if we are changing X, Y, Z on our product, then it makes it better for the next generation of our component or our engines. Yeah, so it is absolutely vital that we understand what's happening in service today.
And what you say there is really interesting. To jump back into corporate mode for a second, the investment that we're making in digital transformation as well as our broader changes within Rolls-Royce is key, because it means those design iterations get faster and faster. And there's a story out today about us working with some partners. This is looking quite far ahead now, of how we're with respect specifically to a thing called computational fluid dynamics, which is the modeling of the movement of air through our jet engines. Massive calculations, billions and billions of cells on spreadsheets that might change every second in terms of the variables they have to deal with. Calculations that can take months. But we're exploring how we can use quantum computing to bring those months worth of calculations down to a day. Wow. And then your design iterations get faster. Yeah, of course, the production of new products becomes quicker, cheaper, and so on and so forth. So we're not just looking at the in-service data for now or for the next 5 years. We're actually looking at how we can use that and how we can shape that and put it in a form where it's compatible with quantum computing, as opposed to just being compatible with classical supercomputers. So it's a very long view ahead of that type of technology that allows us, in reality, to bring products to bear much, much faster than we do now.
Yeah, but then again, by definition, we said that very often on the podcast, this industry is an industry with long timelines. So when you look ahead, you need to look ahead, because the next engine coming from the next aircraft, we're talking about life cycles of 20 years of development. Especially nowadays, the development seems to be faster. When you look at the development of a 777X, I don't even know if you're involved at all or not. The point is that it seemed to be lasting longer. So this aircraft would then be in the air for a very long time before a forthcoming iteration or variant comes on. So you have to look forward in the future, because if you don't, then if you miss one boat, this is not the next one coming, not the next 5 minutes. Then you wait until the next one. So you have to be, Do you?
And just picking up on that, future forward and planning, sustainable energy, renewable fuel. How does that kind of come into play now? Like, you're making these fantastic pieces of machinery based on the fuel of today, or maybe not. Maybe there's more.
Well, yeah, I mean, it's a great question, and it's one that's kind of been on the tip of everyone's lips for a few years now. There are three aspects that we look at in terms of how sustainable flight can get. The first one is efficiency. A lot to do with the stuff that Stefan's working on that enables efficiency. So hotter engines that can run more efficiently. Whatever you put in your engine, you want it to be efficient. So it's almost fuel agnostic. But gas turbines and fuel efficiency are kind of absolutely the first priority. They're also the way you can have the quickest impact on things like carbon emissions and non-CO2 emissions. We've already proven with regards to the second thing that we look at around sustainable aviation fuels or synthetic aviation fuels, that all of our current products are compatible with 100% blends of SAF. Regulations say that you can only have a 50% blend anyway, but we know that our engines are compatible with 100%. The actual strain on that progress is the supply and the cost of SAF. There's not much of it, and it costs an enormous amount of money.
Yes.
And then the third tier is the kind of over the horizon fuels, which we categorize as cryogenics, and within that you've got hydrogen. We've done a lot of work on hydrogen and proved the sort of technical capability to use it in terms of it being used as a fuel. It's very difficult to do that. It requires a change of systems and infrastructure across the whole of the aviation kind of network, whereas SAF is drop-in. What actually we recognize is that hydrogen is a critical component of manufacturing SAF, and so actually the interest in and the excitement around hydrogen for us is a lot around how can it be produced in a way where it's supporting as a feedstock for SAF production to get that earlier impact in terms of sustainability.
I think in terms of burning hydrogen and actually using it to power an engine, that leap isn't that great. It's more as Ben said, sort of the infrastructure. How do you store it on the ground, especially on the plane? So integrating it in today's airframe, that's a much bigger challenge. And having a solution, especially for long haul flights, where you want to keep the aircraft as light as possible. Having some pressurized fuel vessels, they are very heavy, isn't it? So that's not an easy solution to fly for 8 or 9 hours across the Atlantic, isn't it? Yeah. So it's all those considerations that not necessarily our job as an engine manufacturer, but within the industry, those are obviously big problems that need to be resolved. Yeah, and that's where hydrocarbon fuel, whether it's Jet A or SAF, is still the most competitive solution, and you just have to sort of weigh up how to produce it. How do you not create an industry that competes with food production and all those kind of things? You have to. What other environmental impacts do you get with SAF? It sounds like great. Oh well, I create SAF fuel. I don't get it out of the ground. But there's all sorts of other implications you have to then consider with that as well, isn't it? So it's a big multifaceted problem that not one person alone, one company alone will be able to solve.
And do you or would you get involved into, because the aircraft's engineering has been so good that the sad part is that all the aircrafts look the same nowadays-ish. I know that, but I recognize that 350 is my favorite one, but that's personal. I recognize it especially because of the front, but a Dreamliner looks really nice, but they all look, there's not that much variety there used to be like in the 60s and the 70s with a TriStar, the Concorde, etc. But we know that airliners, Boeing and Airbus, are off and on, depending on economic realities, are looking into the aircraft of the future. They always call like this. when that happens, and maybe it's happening now, are you getting involved sometimes? You try because they need an engine still, but maybe for a type of aircraft that doesn't exist anymore, so they couldn't that doesn't exist yet. Pardon me. So it's not a traditional. So is that something you don't need to tell me if it's something that's happening and you cannot talk about it, but that's something that you're ready to look at when let's say if Airbus or Boeing comes and said, okay, this crazy aircraft that can probably exist in 40 years and that will be way more sustainable, but the engine will have to be completely different. Is that something you can?
Yeah, I think that for us, it kind of goes back to what I said before about our focus. There are a million things we could get into which are fascinating, but ultimately they also might be distracting. And so our focus has been on proving that there are no technological barriers to, the use of SAF in current gas turbine designs, and that we see a pathway where hydrogen could possibly be used in some kind of combustible form for a jet engine. As Stefan said, perhaps the leap for that's not so great. It's the infrastructure around it. But actually what our focus is greater efficiency, greater durability and greater reliability now, because it's not something that we can solve in terms of SAF production or so on and so forth. We can prove the technological compatibility of our current products and probably the sort of the next 30-40 years worth of gas turbines for aerospace use. We can prove that's compatibility with SAF. Beyond that, it's a whole society effort to kind of bring those things to bear. And with regards to the design of aircraft, absolutely, I think people expect that airframers will be looking at what does the aircraft of the future look like. I think if you look at like you say, the sort of the homogeneous designs of aircraft, passenger aircraft today, particularly passenger aircraft.
Maybe because they're good, but
maybe it's because it works.
Exactly.
And maybe
it's a good compromise.
Yeah.
Well, in engineering, a lot of it is about compromise, having an appropriate compromise. Yeah. And one of the other things is also the passenger experience. It's like one of the things you quite often see. So everybody likes a window seat, isn't it? So a more efficient airframe would have been potentially like a blended wing body.
Yes.
But then nobody's got a window seat.
Yeah, but then again, Emirates does. I've been lucky to fly once the first class Emirates on a 777, and you have the
screen.
The screen.
Yeah.
You don't see the difference.
And essentially create a sort of a virtual environment as if you're looking out a window.
However, I always said the bad thing is if you give that to certain low cost, and I'm not going to say a name, there's going to be ads running on it, and not any side view on side. So I'd rather maybe, but you're right. It's a and also the passenger experience has to be cost effective. We can create crazy things. But if they're too expensive, no airline will ever buy them.
But the other concepts may be more efficient ways of flying. So from that, if you just look at the efficiency of getting from A to B, that concept would be a more efficient concept. But again, you have to sell it to the market. And if you bring out something radically different, people initially say, I don't want to go on that. Yeah, and that's another aspect. And do you want to develop that technology, spend all that money to then not sell it?
And we've seen just with the 380, which was still an aircraft just bigger, that he required sometimes to expand the runways, the taxiways, and the
special
gates. So it was already, and it's still a similar aircraft that we know. So if you have something completely different, maybe like jetties have to be replaced, and then it's also back to your point about SAF and the infrastructure behind it takes time to pick up. And we've seen yesterday when I was driving here when this first stop on the motorway, on the highway. And at first I was like, there's no petrol station here. There's only electric. Of course there was. I had to find it. It was slightly remote. But the point is, it can happen.
Yeah.
So maybe with SAF it will happen because at some point there's incentives. Maybe it's the government, maybe it's regulations. But at some point the infrastructure catches up. And then you guys seem to be, at least for SAF, ready. So
with SAF ready, I think that's a really good way to put it. And I think if you look into the SAF topic and the feasibility of it, it's pretty broadly agreed that that's the after efficiency, that's the quickest and most impactful way of reducing CO2 emissions, looking at how it impacts non-CO2 emissions. You look into SAF, okay, well, it's got to be generated with a huge amount of power. Is that power clean? What about the feedstock that goes into SAF? Oh, we've got to create loads of hydrogen. What is that, green hydrogen, or is it pink or purple, whatever the color hydrogen is this week? So the more you go into it, you go, okay, well, so what do I need? I need a massive amount of steady baseload electricity to complete that. I think it's the Fischer-Tropsch process for creating SAF. Well, what's best for that? Well, it's got to be carbon free, right? So that's nuclear. It can't be wind because it's not stable, or if it was, it would need a fields and fields of batteries to stabilize it. So the further you go into it, the bigger it gets, and that's why I think, like Stefan says, it's not one company that can solve it. It's a societal effort to transition to that.
Yeah, of course. And because of the long timelines of the airline industry, it takes also longer. It's like the example I took was a bad one with cars. It's the timeline is accelerated. You can make change happen faster, and people having, and you still see resistance. And I understand sometimes the resistance. I myself, when I had to choose the hire the car, I had a choice with a long range electric. I was like, nah, I'm not ready yet. See, there's also that, right? But talking, you just said about compromise, about the passenger experience. We talked about the windowless plane, which might happen one day. Who knows? But one other thing and I'm not here, it's one of the talk on the industry, and we know, is for short haul, so it doesn't concern you, single pilot operations. And of course, one of the arguments from the research is that single pilot operations is now a possibility because engines are so reliable. Right, so you're responsible for the we might have a single. But are these discussions happening? And I'm not talking about because but when you meet all these other guys, maybe at Dubai Air Show, is that do you hear this type of discussion? Is that something that they tell you? Do they want your opinion on it, or is that something that appears in your radar at all? I don't know.
No, it's not. I think that's it's in the bucket of unintended consequences for having a really reliable engines. No, I think our envelope for interest is very much in, is it going to do what we say it's going to do, and is it going to meet our customers' expectations? So no, I don't think we get into that, but I am aware of what a prickly topic it is as well.
This really sheds light on how small, and this is kind of going towards the Abgeek side, how small the aircraft world is at the same time, but also hinging on what's exciting in development. Because the more and more efficient engines you have, we start to dinosaur out some of these well-loved aircraft. The 747-400, efficiency, rest in peace, right? The 777-200, the massive fuel tanks. Do you need the massive fuel tanks anymore? Not necessarily, but maybe you can to go around the world. But it sort of starts to put bricks on, for at least for the generation of us in this room, which are kind of around the same, the aircraft that we know and love. What are our children going to be flying on? That's going to be exciting to see.
Yeah, it's going to be fascinating. And last week when I went to the Dubai Air Show, I had my first trip on a A380.
Was it your first?
It's my first trip on it.
Oh wow!
And it's already ceasing production. So I'm like, well, how many more are we going to get? Because it was amazing.
Did you like it?
Oh, it was fantastic. Yeah, it was like an entire town going on a plane, boarding. It was crazy. I've never seen anything like it.
Were you on the upper deck?
Yeah, I was. Yeah.
Oh man.
Yeah. G7 on the way out. 7G on the way out and 7B on the way back.
Fantastic.
Oh, so you were in business class?
Yes.
On in the upper. Oh.
Where did you fly from?
Manchester.
I've never flown a long haul from Manchester. But the 380, this is why I love the 350, because the 350 is the child. No, maybe not the child, but I mean, you clearly can see the lineage. All that they couldn't do because the 380, okay, fine. Sadly, it's dead. It's not a very nice plane to look at. It's not as iconic as a plane, but inside, the passenger experience is fantastic. And I feel that the 350 took all these lessons and applied it. So for the passenger perspective, when I say it's my favorite aircraft, it's because it's just a great aircraft to fly, especially super long haul. Yeah. I've done, 12, 13 hours. The longest I did 14 hours, I don't remember. I didn't do the Perth thing, so no, not that one. Not the one with Qantas. But it's just a fantastic experience. So I'm happy. I'd never flown the 3.
No, it's my first one. And
Did
you know,
were the engines Rolls-Royce? We didn't check.
yes, of course.
No, of course.
900s, 4 of them, I counted.
From way up on your screen.
Yeah.
I guess you still service. Do you still service those? I mean, as in you still do the maintenance because Emirates is said they will run them until 2042. I think so. It's
true. And at Dubai Air Show, actually, we signed an agreement with, or an MOU with Emirates, that they would actually look after and do the MRO activity on those Trent 900 engines in Dubai. So they would establish a maintenance base for them in 2027, I think it was. So.
Oh, so they're even investing so they have long haul plans. Yeah. Wow. So see, even though they ordered so many 777X, which whenever it comes, it's not a diss against the 777X. It's just that guys, you promised us like in 2019 or something, and we're 2025, and it's maybe going to slip to 2027 now. So I'm like, but it's going to be a great aircraft. So I lost the train of. Go ahead, because I had a question.
I'm just keeping an eye on time before we have to start wrapping up. I do have a technical question about something else. One of the things working on the ground, I had a lot of A330-200s and the 300. There's the Trent 700. It had that amazing howl. Is there a secret sauce as to what that's about? Maybe you're not allowed to say, but whether you're in the terminal or they're on the runway, you could hear it. When you're in the cabin, you just know, and it's like, oh yeah. It's here.
So obviously, there will be, and every component there will be a level of vibration. So every turbine blade or every component, it's like a little tuning fork. Yeah, okay. So they all have their own resonance frequency, and depending on obviously what's going on and how the engine setting is, they're all vibrating a little bit. So each engine will have a distinct, in the same as car engines. You drive around and you hear, oh yeah, that's such and such a car, because they have a distinct sound, isn't it? And it's just all the vibrations within those engines that create those sounds. But again, it's an aspect that we have to engineer and make sure that we have a safe product, because vibrations can lead to instant component failure. You've seen all these sort of things like that bridge was swinging in the wind and was breaking apart. That's because the bridge was excited by a resonance at its resonance frequency, and therefore one was shaking itself to bits. And we do the same thing with our airfoils in our engines. We need to understand what is their natural frequency and need to make sure that we dampen out any vibration we're getting out of those ones to make sure they survive and we have a safe product. But there is an underlying sound that comes from those engines, and that is part and parcel of it. Yeah,
I hear that sound about 4 or 5 times a week, because where I live in Chester in the UK, it's close to the Broughton Airbus plant where they make wings, and the Airbus Beluga XL flies over the house about 1,500 feet 3 or 4 times a week.
Really?
And you can hear it before it arrives, and it's epic. It's just unreal.
I've seen the Beluga twice in my life. I just need to come up.
Summer barbecue.
It's
Ben's house.
It comes in before it circles into Broughton.
No way.
Fantastic.
It's unbelievable, and it defies, a bit like my experience with the A380, either being on it or watching it, and it's back to my kind of childhood passion for aviation. How the hell does that stay in the air? I just can't understand it still.
Maybe because we need to wrap up soon because of time constraints. Let's do a little bit of AvGeek, like the usual questions, because you just said childhood passion for aviation. So you always had a passion for aviation since you're like. I'm going to ask you the same question in a minute. You always wanted to be involved in aviation somewhat, or
not about the involvement particularly, but I lived in just in the northwest, in the home counties northwest outside London, near the Beaconsfield stack for Heathrow. So I lived in a place called Chesham in Buckinghamshire, and the aircraft would stack over our house, and you'd see them circling, getting lower, and then going into final. And so already I was like, wow, that's incredible looking at them from the garden. My dad always used to travel a lot as well when I was a kid, so he'd always bring back tales of aircraft and his own passion for aircraft, amenity kits from back in the 80s, whatever.
True, real ones.
Yeah, exactly. And so I was in awe from the start. from when I was really young, I was like looking up, going, "Wow, how on earth does that all happen?"
And can you just, in short words, tell us? Because I don't think we addressed it. You worked at Thomas Cook.
Yeah, Thomas Cook Airlines.
It's an airline, yeah, guys. Yeah,
Yeah,
sorry, when I
as
say
it
Thomas
was.
Cook is an airline. So, and you were doing similar job that what you do now, like
Yeah, that's it. Communications job, PR job. So I was there from 2015 to 2017 or so.
How do you like that? Did you like being like in the industry that you admired as an outsider?
So I worked at Manchester. I was based at the hangar in Manchester. And used to have my sandwiches for lunch in the cockpit of whatever aircraft happened to be in for maintenance that day. 763s was my favourite because it was stretchy.
763, yes.
Yeah, and so we would have the aircraft from the fleet rotate through there for their various checks. 763s would be Condor aircraft, and then the Thomas Cook Airlines aircraft for the UK and Scandies would be the A330-200s, or a really lovely and growing fleet of A321s, and then a couple of really special 752s as well, which was really great. And they retired on my watch as well when they were there. So we had a bit of a tear in the eye when the last one of those was retired.
Did it give you a better appreciation for the work that people do in this industry?
Oh my goodness! Principally, so I did. You do these days, and I was in the cockpit going out to Tenerife and back in a 763 one day. I spent some time on the line on turnaround, and then also had cabin crew experiences as well. And yeah, I think out of all of it, the cabin crew experience is the one that I admire the most.
It's here as well. One of the
just
why
my message to be courteous to cabin crew, be polite. Alex goes on about this all the time. I think just don't be stupid. They're there for your safety.
Yeah,
Number one, they're there for your
Yes,
safety.
yes.
How can you argue with that?
Yeah.
It's just I really respect
and
them.
there are people at the end of the day. So you feel that in some context, and I've been lucky for your context. I've been lucky to fly a lot in the business class, and some people, just because they're in business class, think that they own everything around them, from the seats to maybe the engine, actually, to the people serving them. And you're like, they're still human. Just talk to a normal human being, and you'll be okay. Sometimes it really pisses me off, to be honest. but yeah. So, did you have a passion for aviation?
Yeah, from a very young age, whatever. So where I grew up with my parents and my brother, we always into planes or cars, engineering in general. So always sort of from a young age, my path was set onto engineering, or either being a pilot or working in engineering. And because aerospace is kind of the most interesting, most challenging part of engineering, that's where my sort of career choice was set very early on in my life. So I always and playing geek and been always that. Yeah. So to work, as I said early on, to work in this industry obviously it's a job.
Yeah,
but we got lots of fun and lots of interesting stuff you do with it, isn't it? So it doesn't feel like a chore to come into work. Yeah. It's enjoyable. Don't get me wrong. There's always annoying things for every job. Every job has got some annoying things in there. But I don't mean today. But it is really a great industry to work in, and it's just a great challenge as well.
Do you have a? Of course, maybe your answer will be influenced by the engines, but do you have a favorite aircraft? It doesn't have to be one that still flies.
351 Mustang.
Oh. Why?
I don't know. In terms of
the design, maybe.
Well, the design, the styling. So that's such a beautiful aircraft, especially with a Merlin engine in it. Yeah, yeah. But yeah, that would be my favorite plane.
And as a passenger, do you have a plane that you favor?
I agree with you. The A350 is definitely a stunning aircraft because it's modern and it's got that sort of. Taking them all the sort of learning from past history and everything. Yeah. Obviously, I once had an opportunity to fly Concorde. Unfortunately, I didn't take the opportunity, which I've regretted ever since, because only 6 months later they had the accident and everything.
Damn. Oh.
But that's one of my biggest regrets in life, that I never flew on Concorde. Yeah. But at my height, it would have been quite a cramped flight. So,
you're so tall. Yeah, that's that. I think people we romanticize that aircraft a lot. It was very practical. It's beautiful. I wish it still existed. Yeah, the seats There's one which is the one you can actually sit on. There's one example in the world you can actually go
And sit in the Concorde seat.
Yes, I think so. I don't know. I don't remember if it's either. I've not done it, which is why otherwise I would remember. Obviously, I think, or maybe the seats are next to it and you can sit. It's apparently it. Yeah,
There's one in Manchester that's got the seats to the.
Yeah, I was going to say. I think it's the UK one.
Yep.
Oh, there you go. That's
Yeah.
maybe the one
I
I've
think
heard about.
Duxford as well. I think the one in
Is it?
Duxford has seats in it as well. Yeah, you can't stand up in it. Well, I can't stand up in
No.
it.
Can you refit some engine? You have a lot of parts here. We just put it in the
your own.
Concorde. We just leave with it, right? And maybe it works with SAF fuels as well. That would be it.
I want to just throw a quick honorable mention to the other team member of yours, Ben, that we first met. Because you asked him pretty much, right, how did you get into it? And he told this incredible story of his inspiration of, ending up with the Rolls-Royce team. I think it was, he grew up in, 2 miles away from the original test engine facility, wherever that, he mentioned the place. And the story about, being a little boy in the garden with his mother.
Yeah, outdoors. Engine
right,
test
okay,
facility
fine,
from
yeah,
Rolls-Royce.
yeah.
That because you have used the test beds indoors.
Yes.
You still have outdoors facilities somewhere.
We did have, elsewhere in the world, but not in the UK.
I think he mentioned California. Was it not in California?
Yes.
You have one that is outdoors.
Yeah, might do. Yeah,
Might do anyway. And he said he was living to the one. Yeah, you're right.
Yeah, and at this distance, him and his mother couldn't even talk because it was from miles away, and that's kind of what sparked his aviation. I thought that was just like a really neat
Ben's a
play,
star.
and especially to what he does now. So it was just kind of
that comes to the point I said earlier about that level of enthusiasm because of course. Some people could say, yeah, well, they host you, they want to put a good face on, but that's genuine enthusiasm. Both of you guys here, trust us if you're just listening to us as usual, but Ben as well, and was it Jim earlier?
Jim, and then Mark also in the machine.
Mark, man, you could feel that it comes to what I said earlier, like a certain joy and pride of working there. And I'm sure, like you said, like every job, it's a job, it's some parts. You're like, oh my God, fine. But overall, it's kind of, refreshing, I would say. And maybe reassuring because there's still engines that, carry us around the world. They just carried me here. So not here in Derby, but what I mean. Last question, because we still want to do that. Do you have a favorite, memorable flight that you've ever done in your life for any reason whatsoever? Could be anything. Could be like a memory because it was amazing because you were a kid and you, oh my God, the first time I see a 7.4, or it could be because it was your crappiest flight ever because you had like 2 days delay, or maybe you just say, well, that engine wasn't a Rolls-Royce, so that's why I didn't like it. No, I don't know. So, do you have any?
You go first.
It's for both of you.
The one thing that's maybe memorable, maybe not for a good reason, is when you fly via certain stopover places. Sometimes the people who are getting off on board and off there, they don't necessarily listen to the instructions from everybody. So please remain seated, and everybody gets up, runs around like headless chicken. Yeah, and that's
the
quite
seatbelt sign
quite
is still on.
Yeah, that's right. Yeah, so that's quite a frustrating experience if you're sort of saying everybody's there to basically get safely from A to B, and unfortunately, there are some people who just can't behave themselves. Yeah, and that's sort of sometimes a bit unfortunate. Yeah,
you have a very engineer way of thinking. Like this
It should be this way.
B comes after A. No, I get it because that bothers me as well. There are countries when it's like we're not even stopped yet.
Yeah,
like if you see the poor on the PA shouting to the people, the signal sign is on.
Mine's probably I don't know. My most memorable one. I flew from Buenos Aires to Auckland.
Oh, wow.
Yeah, when they used to do that many years ago.
Which airline was? Do you remember?
No, I can't remember at all. It was 2002 when I did that. And the reason I mentioned it is because I've never come off an aircraft more disorientated, like you were saying just then, after that long a flight, I think about 15 hours, the international dateline, so on and so forth. So I got that, and it kind of makes me look ahead. In 2027, Qantas will do its Sydney Heathrow flight, direct, non-stop, powered by Trent XWB.
Oh, there we go.
Dash 97 on an A350 1000.
Yes,
and I look at that and go, incredible flight, incredible human achievement, and I think we'll hear a lot more about it over the next sort of 18 months or so. how are you? What sort of state are the passengers going to be when they come off that? I think it's going to be
It's true.
a really interesting one. And how the A350-1000 being such a great aircraft,
It
as you
is.
say from your experience, maybe that's enough to stop that stumbling, disorientated passengers coming off.
Yeah, I think to a certain extent. I mean, there's a promise.
That's a long time, though.
You've flown the 350-1000. Yeah,
Yeah.
It's better. You feel more refreshed to a certain extent.
Yeah.
There's no way after like a 14-hour flight.
Well, and mine was in economy as well, so I was even in an even worse state. I was backpacking, so it was really
But
tough.
that's a great that route doesn't exist anymore now.
I don't think they
it
do.
does.
No.
I've seen when I was in South Africa, Joburg to Sydney or something like that. It was Qantas was there. What the hell are you doing? Of course
They did Joburg to Buenos Aires actually.
Yeah.
Yeah. South
Yeah,
Africa.
but
this is Auckland.
This
is a
is
different.
Auckland.
Yeah, it was hefty, really hefty.
It's a great
You
word.
just mentioned New Zealand. When I flew to New Zealand, it was for the Rugby World Cup in 2007. One of the good things on that flight, with the Air New Zealand flight, they had the New Zealand All Blacks rugby team doing the safety video.
Oh.
So everybody paid attention. So that's maybe a good thing for airlines to think about. How can we make the safety videos more interesting for people to actually watch them?
Did you fly through LAX? Which route did you? You flew from here, right?
Yeah, flew from here. Well, via Hong Kong on the way out and LAX on the way back.
Oh, so you did it all around the
Oh,
world.
nice.
Yeah.
Awesome.
I always wanted to do that.
Yeah.
And
That's so
the
cool.
delivery on the Air New Zealand,
Yeah.
all black,
Yeah,
it was so
Yeah.
nice. But we don't
Yeah.
see them at Heathrow anymore. I'm
Mm.
so disappointed.
yeah.
Is there anything else we want to say before we wrap it up? Because then we need to leave these guys going.
Yeah.
And you need to, for context, guys, for those who are listening, he arrived from Vancouver when? Yesterday. We're recording this, by the way, we should say that, the 25th of November.
27 hours ago I landed at
27,
Heathrow.
and you living in...
24 hours.
So he just came for this. So it's a bit jet
I'm
lag.
honoured.
Last
Yeah.
night, we drove yesterday to go for a pub. And I think last night you were crashing.
I was starting
I
to
saw you at
crash.
9 and I was like, I think he needs to go to sleep.
Thanks for making the effort to come and see us. It was worthwhile.
So, guys, thank you so much. I think we'll need to do another one with you at some point because that was very enjoyable. You very... Again, the same enthusiasm that was shown by your colleagues earlier, and for the audience that's listening, guys, you're missing out. You need, if you have ever the chance to visit a place like this, it's really quite impressive. So thank you for your enthusiasm, your knowledge, and for being such, very cool about it. Actually, not it didn't feel at all like I was in a PR environment talking to you here. So thank you so much for the opportunity, and I'm sure the audience will love it as well. Do you want them to? Should I give some links or whatever to your work?
Yeah, sure.
Yeah.
So I mean, I think the principal reason, and hopefully the outcome that the audience gets, is your kind of reactions to what you've seen, and
awesome.
And hopefully,
awesome.
hopefully just peeling back the skin a little bit, taking off the engine cowling of what they're sat next to on the wing when they're next on a long haul flight, because that's it's magic. And I think you talk about pride and excitement and enthusiasm. How can you not be? Because it's just so cool. It's absolutely cool.
Just so cool. I think we'll
Although,
finish on...
unless in the turbine, then it's hot.
Yeah, that's very true.
I wish there was a way that I could track all the engines that I've flown in the past. Like there was.
Yeah, this is an opportunity here for this.
Yeah, this is
Space.
Thank you, Go. Cool and hot. We had both cool and hot here. Thank you so much, guys.
Thanks for
this.
coming.
Welcome.
Thanks, guys.
Thank you.
Great.
How cool was that, Vinod?
Did that actually just happen? That's got to be the highlight of the year.
Oh yeah.
And also the fact that we were both there together on the same plot of land. That never happens.
It was the first time we did a podcast live together. I mean, I even didn't realize it. Of course it was, but I was so focused on trying to make this work. And by the way, we were both jet lagged.
Oh yeah.
Like quite a bit. You more than me. So tell the people, I mean, don't tell the flights because we'll do a separate episode about that, but when did you arrive?
So I took off from Vancouver, Canada on Sunday evening, landed into Heathrow on a Monday at noon.
Yep.
You picked me up. We drove up to Derby, spent the night, but didn't really sleep because the body clock didn't know what was going on. We did this on a Tuesday. Tuesday evening, we drove back to London.
Yep.
Tried to sleep again. And by 14:30 on Wednesday, I was back on the plane flying back across the Atlantic to Canada.
How's your body today?
It honestly doesn't know what's happened. It's,
by the
it's
way,
one of
for
those trips where it doesn't know that it actually went somewhere and came back, I think.
Yes, exactly. It was short enough, but I used to do this with Asia when I would go for 2 or 3 days. So I know what you mean. For context, this is recorded the post game commentary, the intro you heard earlier at the top of the show on Friday, so November the 28th. So just a few days after we did this. Before we go further, I really want to, and I do that on behalf of Vinod and I really want to thank everyone at Rolls-Royce. I want to thank Ben first, Ben Todd. You've heard him during or seen him if you watch a video. Ben, you're a star first for having reached out to me, reached out to us, having invited us. He's the trigger. He says, you guys should come. I was like, what? It's not every day you have like these companies that are like behemoth that have all this heritage and are so awesome inviting us. So really thank you for having also agreed to be on the show because, I really wanted to, and this is something I always like to do to kind of showcase is not the right word, a fan, fans, people, not that we would only accept people who love us to be on the show, but I really wanted this component. And so, Ben, thank you so much. You have a fantastic personality. You heard that, guys. I don't need to tell you. He's just fab, by the way, and I think you sensed that throughout the conversation. And if I may add, on a personal note, I hadn't met him. I had a calls with him before, of course, but I hadn't met him, and I meet a lot of comms and PR people in my line of work outside of this life of layovers, and he is one of the greats. He's really, really good. He's just that good. So thank you, Stefan, as well. What an amazing brain, right?
Completely. Like the amount of knowledge and commitment to what he does it was great. It was just and it was great to feed off that passion too.
Exactly. And he's a great educator. I thought he had that great balance of a bit of a geek educator. He was both serious but understood the tone. Really, I think he was an all-around marvelous person to listen to and also to hang out with after, because he's the one who actually got us to the parking lot afterwards. So,
that's true.
So, thank you, Stefan. The other Ben, you mentioned him during the show. He had this kind of infectious, geeky enthusiasm, right?
Totally. Yeah. When we first met, I was like, where are we going with this? And then he just starts spilling into us. And next thing you know, we were maybe ready to work there, be put to work.
This is exactly what I was thinking. Like, I want to work at that company. When I meet all those guys, he's the first one we actually met when we arrived at Rolls-Royce. Is that the other Ben? Sorry, Ben. The other Ben was the one that we met, and he did us a tour of the first factory we've seen with the blades. It was really fantastic. Also, Mark, in the other factory. He was so welcoming to us, to this factory floor, and very warm with us. And he also let us play with the quality control. Let's be clear. The engines are safe. We haven't played. We didn't mess with them.
Someone was still watching over us.
Yeah, and that dude. I'm sorry, I forgot his name.
I didn't even catch his name.
Yeah, exactly. He might have said or not, but anyway, that dude for quality control, it was so cool. Like, do you want to sit? Like, go sit, try and play.
I mean,
with
here
the
you and I come babbling along. He's like, "Oh, why don't you try and have to do my job?" Like, okay. So thank you for that. That was amazing.
That was really amazing. So thank you. And again, that shows. I think people you getting the point. That shows the philosophy of the company. It was all throughout very open and very engaging, but not PR point of view, like real people, real chaps just wanted to talk and share what they do, and it was really fantastic. And also Jim at the operations center,
SCC,
SCC, I think.
Yeah.
It's been a few days, and I'm also jet lagged. I should have said, when I was asking you about jet lag, I was coming from New York, which is a much shorter travel time than you, through Munich and back to London just the day before. So I still jet lag. I'm still, last night I couldn't sleep well. So my brain is still mushy. That's age probably. But anyway,
well, I think the fact that you were jet lagged, I was jet lagged, and we both had to just keep talking during the drive in the dark so that we made sure we were staying on the road in the right way.
Well, though that car,
That car would have.
yeah, well, I'll talk about the car a little bit later. Actually, there's a reason, guys. It's linked to aviation, linked to travel. So Jim, the SCCF, I forgot the name. I'm really sorry. Yeah, sorry, it was too short, but he was so educative. He gave us all. It was fantastic to be there and listening to how they do this. And you know what? My feeling, I don't know if it was the same with you, is that not only, they had the enthusiasm and great philosophy of work and they were engaging, etc., but I feel safe with all those guys.
Yes.
As in, right?
Knowing
I feel
that those are the people behind and watching and monitoring, I'm like, okay, it's right. The system is right.
Exactly. That's something that I just felt that way. Like, and so he makes us safe. He made us happy. To do that, such bright minds, with such great personalities, are making the engines that allow us to nearly forget about the engines. You know what I mean? They're making them so good that you don't think about them, which allow us, you and me and Alex, to bitch about stuff like, the seat is not great. Oh, the food.
Exactly. Engines are fine, but that crew member. Oh.
Or the livery, we don't like the new livery, the color they chose. So the work you guys do at Rolls-Royce allows us and people and the traveling public in general to not overthink about the rest. We're just reassured, and it was even more reassuring to see you guys in action. But yeah, now you're the reason why we're doing this podcast because we can talk about all the rest
exactly
without about thinking them engines. So I'm so glad you guys exist and make that possible. And one more reason to love that industry. In general, the aviation industry with all its components, from the people we see front-facing passengers to people in the back, because at the end of the day, Rolls-Royce, we see the brand, we might know the engines, but we don't really know them, and that was fantastic. And all this industry is really, really fun, really fabulous, and also a little bit of a flag raising here. This is also why I love this country so goddamn much. I mean, the people were so cool, so I'm very happy.
Yeah.
Any standouts for you? Do you have now, a few days later, of course, your brain is also mushy. But do you have any moments or any things you want to share? Whatever, basically.
There's so much. I mean, what you mentioned earlier, the human touch, and one of the things that really struck me was, you think of it's 2025, almost 2026, 21st century. The Industrial Revolution happened already, but there's components of the Industrial Revolution still at work. And what I mean by that is there are still amazing human beings making things.
Yeah.
And we went into the one section of the casting facility, and there were workers, in pods doing work by hand with the human touch. So, yeah, we saw a lot of robots, and we saw a lot of the use of words in microns and analysis, but there was also humans with their eyes who were highly trained doing work.
And they told us that it's they have other facilities where there's way more robots, but this is at the edge. This is where they do the new blade, so it's easier to actually do that. When it comes at scale, you can do that with more robots and more automated. But when they do these type of research and this is what we. But I should have asked. I don't know the QC. Do you think the quality control they check the holes every single time with human? It's they had machines, by the way, guys. Let's put it. We cannot. I should say that for those who watch the video. A lot of the stuff we, of course, could not film or could not take pictures of because, of course, it's proprietary. I will say that word.
Yep.
Thank you. Thank you. That's why I have this guy with me. But you could see that they really invest in a lot of technology. So don't misunderstand, because you haven't seen it and we have misunderstood this as something like, oh, they're just basically only human. No, it's human supported and augmented by a lot of technology around, and quite stunning technology. But you know what? You made me think about one point, is that you said when we met Ben, the first Ben, with that enthusiasm, was it when he was talking about the casting?
Yes.
And for the casting, they were using wax. We're talking about a technology that is so ancient.
Yes, exactly. I thought it was like, the demo he's talking about is wax, but what they're really making is like, I don't know, some element that we have not even heard about. But no, it's wax.
It's wax. It's wax. So it's amazing to see the use of these I would say ancient. I even think he used the word ancient technology, but for something ultra modern. Because I don't think, did we say it during the recording? Again, guys, it's been a few days, but that each blade is grown from a single crystal is actually, if you think about it scientifically, and I'm no scientist, it's pretty insane.
Yeah.
It's absolutely insane. Of course, it's to prevent the blade from stretching and from creaking. But it's just insane.
It is.
There's actually a video, if you want to watch on YouTube, for Veritasium. It's a very large science channel. They have done a video, Rolls-Royce, just before us. We're in the same league. I don't know about that, because they are much smarter than we are. Where they explain some of it, so you guys can watch that. Veritasium. Anyway, so what I loved is this, like you said, this. The fact that there were a lot of humans at the same time, the high technology, and that gave this impression of living both in the future, but with a great anchor in the present, and of course in the heritage, so in the past. But some of the stuff was really at the edge of physics, right? So even though they were using vaccines, the alloy, and like, what?
And one of the other things, the size. So when we were there, we were looking at this, kind of display that had all the different processes of casting the turbine blade. So I think, most of the people, when you say, oh, we're going to go see airplane engines, they think of, the big, on a 777 or A380, the big fan blades.
Yeah, the one in the front, yeah.
The stuff we were seeing, what 6 inches, 8 inches, and that was the big version. So when we went from that display, I was like, oh, that must be the mini version. Well, no, that was the actual thing. But I thought, I had on the flight when I was going home, I was like, what exact part of the engine again? Because we saw a lot of diagrams, and it's the true core. Where the temperatures go to, I think, was it like the Earth's core, pretty much?
I think you said 1500 centigrade.
Yeah,
and the melting point of the metal is 1250.
2 times back or something.
So it's like exactly. So basically, and that's why they have the holes. I don't remember again if we explained, but that's why we have. Yes, Stefan did. That the holes and the airflow, so the ridges built on each blade, and the holes so that there's airflow, and there's of course coating as well. They have a crazy coating that makes that the alloy, which is a very, very, very advanced alloy, but still it gets too hot in the engine, so it needs to have these so that it doesn't melt. That's also, again, the edge of the laws of physics, or as I'd like to call it, witchcraft or sorcery.
Completely. It makes me think of that. We were just in that movie, the older movie, The Core, where they go on like that sort of train thing to the Earth's core. It's like completely Hollywood in this man-made witchcraft machine. But with that then came, I think, and we probably didn't touch on it during the actual recording, was the amount of forces that these things are subject to.
Yes.
It was, I think, on one turbine blade, which is, I think, what they say, 6 to 8 inches, it takes the force of, was it 2 double-decker London buses?
Yeah, it can hold 2 double-decker London buses. I think that's 20 metric tons. I think that's the number. Ben, again, that's the first Ben. The other Ben, again, Ben, sorry, that gave that number. But the image, imagine, yeah. So and also, each of them, in terms of power, is one Formula One car.
That's right.
One Formula One car.
The average engine has, was it 68 blades, I think, right?
68 blades. So there's 68 Formula One engines in each engine. That is, so you have 68 multiplied by 2 on a, oh my God, So see, we talked about Formula One. We thought about it.
Yeah. We're on the motorway.
Exactly. So these are the kind of things that are, you don't think about them, obviously, but when you see and when it's so well explained, and we're probably doing not the greatest job here, Vinod and I, because we're not specialists, it's absolutely insane to see. And if you guys are ever lucky to being able to be invited, and one more, because it was really funny, this mix of modern and old, that single crystal that they're being able to make, the way it's possible, it's made possible, is that pigtail, you remember?
Oh, yes, yeah.
On the casting.
Yeah.
So again, this is not like some crazy it is an invention, obviously, but it feels like very analog, and it gives a result that ends up being in the the most forward, the most futuristic type of technology that allows us to fly. That contrast was all throughout really amazing. Another thing I want to talk about is that screen, that massive screen.
Oh, can we make one for our houses? Like, I just want that.
Remember when we were driving back, I was telling you, like, guys, because this is what I was thinking. When he mentioned that the first time, I was like, would it be when one of these Hollywood sets, when you have like massive screens everywhere, like flashing lights, and a guy in the middle with headphones like the ones I have now, like an aviator sunglasses and a telephone there, give me the president, you know.
And then like a hologram that he like swipes across or something.
Exactly. This is, you know, actually it was very, and reassuringly so, very, not silent, but very smooth.
Yeah,
the entire
it was very tranquil. The whole room.
Tranquil.
And it wasn't, you know, the room that you mentioned out of Hollywood would be something you'd find like 80 feet under the ground. This was just in the middle of an office level.
Yes.
I mean, it was walled, it had glass, but it was bright and airy and open, which I think, you know, should they have to react to something, it's a nice calm environment to like get through and think things and go through the logic of everything that's happening.
I think the term logic of everything, I think that's exactly it. That it's not like, again, Hollywood, like in people and flashing like in sirens and alert, there's a plane in pride, there's an issue. It's like there's like almost like a checklist, like they know what to do. And that's why I said it feels not reassuring. Not that I was not reassured before, but I didn't need to be reassured. But you felt everything is like more than under control. They know what they're doing. And that's something that is almost like you want to show that to people who have anxiety with flying. Like, look, these guys can know there's an issue or potential. It's not even an issue. They were telling us that like it's how they can feel that an issue could be arising because they have data from the past. Or something that is slightly out of line. So that's super reassuring. So before it happens, before even sometimes a pilot knows about it, right?
Yes.
So, and of course the airline knows about it. So meaning, when I say reassuring is like, for people who have anxiety or fear of flying, is like, guys, you're being handheld very, very well here, because the repairs that should be done maybe in 3 months, anyway, like when I say repairs, I'm talking maintenance, will be done maybe faster, because they, you know what, we'd rather, and they gave us an example, Jim gave us an example, where they said, you know what, let's change this during the layover, it's better. They didn't need to, but since one sensor was slightly out of normalcy, they said, you know what, let's change it anyway. And you're like, this is the kind of stuff that makes it that you never think about the engines, is because these guys work in the background, and before anything happens, and thus nothing actually happens, which is actually pretty insane.
Yeah. There was a slide on one of the things that Jim had presented, and it was a very powerful statement. It said, "We are monitoring the world's largest airline."
Yeah.
And it was a great statement, because even you know what's one of the Emirates? Okay, they're going to be. I'm sure they have a similar monitoring center, and they're monitoring how many Emirates flights are in the air at any one given point in time. A few hundred, I would think, perhaps maybe 100. Let's say 100. I mean, these guys are monitoring thousands.
Yeah, I think they said. I think Ben said, I think, didn't he say 3,000 engines at any point in time?
At any point in time. So at 1,500 planes. 1,500 planes. Yeah. So they're monitoring the world's largest airline, really, which is true. Yeah.
True. Yeah. It's, I mean, and then also my silly question, I was like, so do you call the pilot? Of course not. But it was really.
You call the pilot's boss.
I played dumb on purpose, but I want to, again, like, so what happens when you see that there's an issue in the, again, a potential arising something in the engine? Do you call the pilot, hey, look left, there's something.
Can you crawl in there and fix it?
Exactly. So that would be the Hollywood version of it, right? Like a TV show like Hijack or something. The other bit on that same screen, do you remember that they had the monitoring of all the flights, and they had a very interesting, a very well done monitoring of all social media, news, etc. So they had, they had the news, so they had aggregators. I think it was done with AI, and I think they mentioned the company, or maybe not, that does it. So, if there's 20,000 news a minute about something, it gives excerpts and summaries, so people don't know, should we react or not. And by the way, it's interesting because one of these things could be an airport could be closing where we were about to send a piece of equipment to being
Yes.
put in an engine. But we know already, because we have this view of the news, that the airport might be closing. So maybe the airline hasn't decided yet to reroute, or the pilot, of course, hasn't decided yet to reroute. But we already have contingency. They would say, oh, these are the 2 other airports they might go, so we can send a piece there. So that was actually very interesting. But the social media one, when we were there, I think the central column, they were, how many people die every day in an airport, man?
It's something you don't associate the two. No. But there were
guys,
reports there about something going on.
Guys, we're talking, it's not like every second, but you were talking like, they have really they go very, very detailed, because they want to know everything that could impact operations of an airline, of an aircraft, of, an airport. So you'll have, when I say every day, that with a number of people that go through an airport, you'll have a heart attack. You'll have stuff like that. We're not talking about terrorism or anything. It's just that in front of us, you had like airports. I didn't even know what airports were they. They had the code. I was like, what? Where is that? But you had like, one dead. I'm like, and all this, like, my God, that
was great. All of it feeding into the one screen, and so you can kind of scan it. But you're right. I mean, it has such a huge impact on a news story that you would not even flinch at. Like, I don't know. I think there was one I saw, like a motorway crash in one city. I was like, why would that be important? But, going back to, if they're having to race apart from some city that van is going to be on that motorway, they better tell that driver to go a different route. And they can do that because they're monitoring it. Otherwise, he's stuck in traffic and the plane's delayed.
Yeah, exactly.
Yeah. So it's a whole new appreciation for the passenger experience when, we see it, passengers standing there, why is my plane delayed? Well, not for the heck of it. That there's we've tried, or the system has tried, and it's going to keep trying to write it. Yeah.
And again, humans, it's not all, these, of course, the screen is all like aggregated and it's super well done, but you have humans, and they know, they showed us, of course, this is all, we can't talk about, but they showed us like the current log of stuff they needed to attend. It was not big deals. We're not talking here like a full engine being replaced, but it's fascinating to see, and you could see where in the queue it was, where in the process it was, how the piece is about to be delivered, or it's being at the airport waiting for the aircraft, etc. So it's really, again, I don't need, and we don't need reassuring. I don't think, I'm talking about me. I don't know about you, but I didn't need reassuring, but it is still soothing to see all this, because you're like, wow, actually, they got us, right?
And it doesn't stop. Like, it's a 24/7 operation, and the case, whatever maybe the situation, just gets handed off to the next shift that's taking it over. It's like when you call in to get a deal on your internet, and then you run out of time, and then you've spent half an hour with that agent trying to work the deal, and then you got to go. It's like, I have to call in again and start again. It's the same thing.
Same thing.
But in this case, it carries on, which is great.
Yeah. Yeah, no, it was fantastic to witness all this. The factories, multiple components of the factories, and this more, desk monitoring jobs. There was, and again, every single person we met was fantastic, and also very willing to explain and willing to share. It was, I think that it's great that they allow people like us. I know that, again, Veritasium has been they've been only for the science bit part. So the fact that, what was he using, Ben? What did he tell us? It's like the fact that you put an ice cube in a microwave. That was the analogy for a blade. Right. The ice cube in a microwave. You put the microwave on. You go to work. You go back home after a full day of work. You open the door of the microwave, and the ice cube
is still there. Yeah,
that's how crazy and the edge of physics that thing is. So. That channel has that, but less the whole monitoring. So we were very, very, very happy to see that. So simply, basically, you can feel our enthusiasm here. Simply as geeks, we're very happy. Even if we hadn't recorded this, I would be like, wow. I think my wife would be tired of me talking about Rolls-Royce. Thank God I'm seeing Paolo, who was on the episode 152 tonight Friday.
Oh, good.
And he's going to have the load of me telling the story about again and again about all the cool things we've seen at Rolls-Royce and how cool the people were and how amazing it all was.
Yeah. I mean, when I got on the plane to go back, and I'll save the trip for another episode.
Yeah.
It did not have Rolls-Royce engines. I was like, oh, well, okay. I'm sure it was completely amazing. Also, other make. It wasn't right. I should have planned it. I should have planned it that way.
Yeah,
but don't worry, there's one coming up. I have one coming up. So.
As I said, I came to Munich with a 350, so I think those were Rolls-Royce engines. Then it was a 320. So no, from Munich to London, and we drove with that Kia. So it's funny because when you asked the question, because we were out of time with the recording, there was so much. We crammed a lot in a few hours, guys. So we were time constrained. Also, my setup didn't work. The video setup didn't work as at the beginning. I lost 15 minutes to try to make it work, which is why the video, the angle is a bit like, I just said, I'm that guy, ship it. So I said, well, let's just record this and we'll figure it out. I wanted to head what the content was more important for me than the video angle. But I was thinking when you were asking about, remember the sound of the engine, the howling?
Oh, yes. The A330, the howl.
Yes. I was thinking of, these sound designers in cars that make every part sound a specific way to make it feel, premium or something. And the car we had, it was a Kia. It was a rental. It was beeping all the way throughout because it's one of these modern cars. And I was like, I hope the engine's only beeps all the freaking time because he was. And I mean, it's all safety stuff and whatever. But it was just.
I think that's probably what kept us awake. Actually,
yes, exactly.
Yeah,
and I don't think the car has that thing that the airplanes have. Terrain.
Instead of pull up, it's like turn left.
Turn left. Turn. Actually, the wheel.
The wheel was doing it.
Yeah, I'm going to stop talking about.
One thing cool about the drive, though, just on the drive, is where we went with Derby in the UK.
Yep.
In general, it was just kind of a neat area to go to because there was a lot of other headquarter and production and factory.
Yeah.
We saw like H&M, probably H&M UK division. I saw there was Aldi had their central warehouses, and you mentioned one. I forget what it was. Some other big.
I think it's Tesco that is there.
Yeah, I think that's what
Tesco.
it was.
Yeah, I think Tesco. Yeah, that is there. So
because I was talking about all the shopping I had to do at Tesco, right?
They also have East Midland Airport, which we'll cover maybe one day, is not very far, which is a very big hub for cargo, actually. And we should say Ben lives close to Chester Airport. So Ben Todd, the one you saw in the video, you heard on the video. And that's where a lot of the Airbus deliveries are made. So he sees the Beluga, what did you say, 4 times a week?
Yeah.
I'm so jealous.
Because he's in the flight path and he's just flying around.
By the way, because we had to clear the episode and everything, the content. So I've been in touch with him this past week quite daily. And he's been sending me like screenshots. I have a Beluga above me. I'm like, oh my god, I'm so jealous. I'm very, very, very jealous. He has a great position. I think Chester, is it CEG the code? I might be mistaken. Maybe we'll cover it. We'll cover it one day. Anyway, look, we could have crammed 4 hours of conversation. We had like an hour and 30, hour, 40 minutes with these guys. Yep. It was amazing. So thank you again to all of them. I mentioned them earlier. And I want to thank one more person, is you, because when I had this opportunity, when Ben reached out to me to do this, and I said, well, to Alex and you, guys, I mean, I'm going anyway. Do you want to come? And you said, yeah, I'll come. And I'm like, you sure? You have to take a plane, maybe a day off.
Yeah, and leave a family behind.
Yes. And you booked like right away, like a few hours later, I booked. I'm like, what? So that was super fast enough. So thank you for doing that. But also, these what was it, 6 hours, 3 hours each way drive we did together. Yeah. When I drove and you kept me awake, or I kept you awake on the way back because you were almost falling asleep during the recording at 3/4 of the thing, I think. But
yeah.
It was so very cool to hang out with you on a longer time frame and have all these discussions. And I've learned, I'm not going to spoil it, but I've learned there's a lot of stories we can still cover. There's your wedding. There's your past as a flight attendant partying with Air France, or maybe not. And what was it? There was another one you mentioned.
Brazil.
Oh, yeah, Brazil we're going to do. Anyway, no, it doesn't matter, guys. I forgot
remember.
because my brain is mushy. Anyway, there's a lot of small bits of content that you will have over time. I'm not saying that in the next episode we'll talk about your wedding. It's not the point. The wedding was pretty epic. I wasn't there, but now I wish I had been. So thank you so much, Vinod, for having made all the way. And guys, in case it's not obvious already, which it should have been, but I've never said it, as you understand, he's a co-host, right? He's a third in the podcast along with Alex and me. So we keep rotating. I'm, of course, the anchors. I'm always here, but he's going to appear way more in the future. We have a lot, actually, because you leaving, you're going to tell us maybe in a second, but you're leaving for your usual Olympics duties early next year.
Mm-hmm.
So we'll probably record 1 or 2 in advance so that there's stuff already said. So thank you, Vinod. It was really awesome to spend all that time with you, with the few beers at the pubs as well the night before to fight the jet lag, I guess.
Yeah, no, you're most welcome, and thank you. It was an incredible opportunity. I had to jump at that one, and I mean, just the fact that I could make it work. At the time and the work, other normal work, and finding a flight, which I didn't realize when I was looking for these flights back. I was like, why is it so difficult? U.S. Thanksgiving was 2 days later. So it's this past week. It's this week right now.
Sure, this week. So, happy Thanksgiving for everyone, because this will be just after Thanksgiving. Yeah. But happy Thanksgiving to everyone.
Thank you for setting it up and including me and having me join the
pleasure.
team.
And Ben was very happy to have you. He said that he told me to thank you many, many times. So I'm doing it live in front of everyone. Oh yeah. The other story, repossession of an aircraft, repo.
Repo
of an aircraft.
Yes.
That's a story you need to tell. My brain is catching up like the jet lag. Yeah. Repo, see guys, he's seen stuff. Repossession of an aircraft from a failing
airline. A commercial airline or two.
Exactly. So see, there's a lot of stories coming up. So while I run the music, I'm just going to put this little...
I just want to tell you both good luck. We're all counting on you.
This is not what I wanted to do. This is going to be... What are your next flights?
In less than a week, I got my usual cross-country run. And I think hopefully this time I'll make it on that aircraft that I've been very elusively trying to get on. So,
which one?
Starts with an A, and it has an engine has an engine that howls.
I think I know. I'm not going to spoil it.
But
that's next week. Yeah,
next week. Yeah, and this trip. Oh, actually, now that I think about it, both sectors will have Rolls-Royce engines.
There you go.
So this is all meant to be.
See, Ben, you succeeded. You want people to be aware of the engine, so now we're going to check every single time what engine there is in our jets. As for me, also next week, I'm flying to Athens. For a few days. It's not going to be very sexy. It's going to be an EasyJet flight, but it's always works, and I always like them a lot. I'm in the front seats. I'm very happy, and we'll talk about the rest the next time I see you. So thank you, and happy flying.
All right, safe travels, guys.